commitment to knowledge, innovation, and academic excellence. At the outset, I extend my deepest gratitude to our respected chief guest and eminent speakers who have graciously accepted our invitation and taken time with their valuable to be with us today. Your presence adds great value and inspiration to this academic event. We are living in an extraordinary era of technological advancement. The journey from bits to qubits represents not an evolution, but a revolution in the field of computing. Traditional computers operate on bit zeros and ones. Quantum computers use qubits, which have the remarkable ability to exit in multiple states simultaneously. This fundamental opens doors to solving complex problems at speeds unimaginable just a few decades ago. Quantum computing is no longer a distant dream. It is becoming a powerful reality. It has the potential to transform industries such as healthcare, cybersecurity, finance, artificial intelligence, and material science. From drug discovery to climate modeling, from encryption to application problems, the possibilities are vast and truly endless. This conference is therefore not just an academic event. It is a platform for intellectual innovation and collaboration. It provides an excellent opportunity for researchers, academicians, and students to come together, share their insights, present their research findings, and explore new ideas in the fascinating domain of quantum computing. I strongly believe that such conferences play a crucial role in bridging the gap between theoretical language, knowledge and practical application. They encourage critical thinking, inspire creativity, and foster a spirit of inquiry among participants. As we gather here today, let us remember that learning is a continuous process. The more we explore, the more we realize how much there is yet to discover. As Albert Einstein once said, the important thing is not to stop questioning. Curiosity has its own reason for existing. Let this conference ignite that curiosity in all of us. To all the participants, I encourage you to engage in sessions actively, interact with experts, ask questions, share your perspectives, make the most of this opportunity to learn, network, and advance your career. Remember, every innovation begins with a simple idea and a curious mind. Our institution has always been committed to promoting quality education. We believe in nurturing young minds and equipping them with the skills and knowledge required to face the challenges of future. This conference is another step in that direction. As we move forward in this era of rapid technological transformation, it is essential for us to stay updated, adaptable, and forward-thinking. The future belongs to those who are willing to learn, unlearn, and relearn. Before I conclude, I once again extend my warmest welcome to all our guests, speakers, and participants. Your presence makes this occasion truly special. I wish the conference great success and hope that it provides to be intellectually stimulating, insightful, and enriching for all. Thank you.
Thank you, Madam, for your inspiring and insightful words. Further, I request Dr. Praveen Joshi, Sir, Director of the College, to express his words of appreciation and honor for our distinguished keynote speaker. Over to you, sir.
Good morning, everybody. It's a great occasion that Dr. S.C. Gulhane, Prerna College of Commerce, Science and Arts has organized such a wonderful conference on a very important and very relevant topic, that is bits to qubits, quantum computing and beyond. It's a very important topic in the present world. The chairman of the inaugural function, Dr. C. Gulhane, Honorable Secretary, Prerna Mandal, the chief guest for inaugural session, Dr. Ravinder Singhal, who is our police commissioner of our Orange City, principal, Dr. Urmila Dabir, the team leader and the HOD of Science Department, Dr. Revatkar, staff members and delegates. It's great pleasure to be with you this morning. In fact, when we speak of from beats to qubits and quantum computing, we basically explore the journey that computer has started about 60 years ago, and now it has reached a very important stage of advancement and progress, that is quantum computing. When we speak of the initial stages of computer, it begins with calculator. And even before that, if somebody asks us what exactly a computer is and how does it function, we have to give the credit to signal system. Because ultimately it's the signal system that is involved in the entire process. So when we press a button of a calculator, it sends signals. From that calculator, we have developed the idea of computing. If somebody asks what's a calculator, we would say calculator is a machine that calculates. From calculation to computing, it's a journey which has taken so many years of its development. Then calculator has turned into computer. Now imagine the first computer, its size. It was very huge. And from that size, it is
I request everyone to please off the mic.
somebody has left the mic on, and therefore there are so many disturbances.
I kindly request everyone to please off the mic. Sorry, sir.
Now the speed of the computer and its capacity to compute has crossed many limits. Now it is 100 times more. But with the introduction of quantum computing, it will grow 1,000 times faster to solve complex problems. The speed will increase many more times. The capacity to solve the complex problems will grow many more times. And it is going to help us in all fields of life. May it be astronomy, may it be astrology, may it be medical field, may it be physics, may it be chemistry, may it be chemical engineering. Not a single field will be left behind as far as quantum computing is concerned. Calculations will be faster. Astrophysics, astronomy, we have to make many complex computations, and that takes years to calculate. But with this quantum leap, we are sure that such complex problems, complex calculations will be done much faster than ever, than even the traditional or classic computer that we call it. With AI support, our computing system is progressing faster and faster. But then, when we all do these things, we have to take into consideration that human brain is not blunted. With the introduction of chatbot, with the introduction of Google, with the introduction of Meta AI, what's happening? The result, the outcome is very disastrous. Our children are not using their brain to calculate the things. We don't use our brain to remember the phone numbers. We keep on forgetting everything and we depend mostly on our mobile phone, which is AI supported. Our creativity is being marred. When students are asked, when they are given some assignment, they don't do it on their own, but they take the help of AI or chatbot or some other medium. Now, because of that, human intelligence is being destroyed. Human creativity is being blunted. The other day I read in the paper that Sweden is the first country which has stopped the use of computer, tablets, mobiles in schools. And they have again gone back to the traditional books and traditional teaching, traditional learning. Because they have seen the disastrous effects that the country is suffering because of the use of AI and other computer resources. This should not happen. When we deliberate in this conference, we have to see how we can go ahead without affecting human abilities, human capabilities, human intelligence. One of the thinkers has said that in this age, artificial intelligence is growing. But along with that, natural stupidity is also growing. This is the age of artificial intelligence, the growth of artificial intelligence, and at the same time, reverse growth of human intelligence. This should not happen. All the scientists, thinkers, educationists, academicians, researchers, teachers, students should take this aspect into consideration that human brain is not blunted, human brain is not affected, human brain is not anyhow, does not get deteriorate because of the use of these computing resources. This conference, I'm sure, will certainly reflect on these issues and some meaningful outcome will be there when the conference ends. This conference should not be an end in itself. It should be the beginning to achieve some higher end in this respect. I apologize that the chief guest of this morning's inaugural session, Dr. Ravinder Singhal, because of some engagement, hasn't so far joined us, but he will join as soon as he gets free. He, being the Commissioner of Police, has certain administrative and legal things to take care of. So far he hasn't joined, but soon he will join us. I welcome all the delegates and I congratulate the Department of Computer Science of Dr. S.C. Gulhane, Prerna College of Commerce, Science and Arts, that they have wonderfully organized this conference, and I wish you all the best for the success of this conference. Thank you very much.
Thank you, sir, for the enlightening introduction. Guiding today's inaugural session as the chairperson, we are privileged to have with us respected Dr. S.C. Gulhane, sir, Secretary of Prerna Seva Mandal Nagpur. I request him to kindly share his presidential remarks. Over to you, sir.
आज के कॉन्फ्रेंस के प्रमुख अतिथि डॉक्टर रविंद्र सिंघल साहब, पुलिस आयुक्त नागपुर, कीनोट स्पीकर डॉक्टर आशीष मिश्रा, डायरेक्टर डॉक्टर प्रवीण जोशी, प्रिंसिपल ऑफ द कॉलेज डॉक्टर उर्मिला डबीर, एचओडी डॉक्टर रेवतकर तथा सभी सहभागी, मुझे बहुत खुशी हो रही है कि हमारे महाविद्यालय के संगणक विभाग ने इस कॉन्फ्रेंस का आयोजन किया है। आज के युग में कंप्यूटर का महत्व अकल्पनीय है। हर क्षेत्र में कंप्यूटर का उपयोग हो रहा है। आज बिना कंप्यूटर कोई भी काम नहीं हो सकता। कंप्यूटर क्रांति ने सारे संसार प्रगतिशील बनाया है और संगठित भी किया है, किंतु प्रगति के साथ साथ हमें यह भी देखना है कि उसका उपयोग केवल मानवीय विकास तथा मानवीय कल्याण के लिए ही होना चाहिए। आज जो संसार में युद्ध हो रहे हैं वे मानवीय विकास के लिए ना होते हुए मानवीय विध्वंस के लिए हो रहे हैं। हमने इस कंप्यूटर क्रांति के युग में केवल मानवीय संस्कृति को आगे बढ़ाने का ही प्रयास करना चाहिए तथा महान लक्ष्य को प्राप्त करने की इच्छा भी रखनी चाहिए। इस कॉन्फ्रेंस में ऐसी बातों पर भी की सफलता के लिए शुभकामनाएं देकर मेरे वाणी को विराम देता हूं।
Thank you, sir, for your valuable guidance. We are truly grateful for your insightful presence and support. We now move ahead to the keynote session, a central segment of today's conference. It is my privilege to present a brief introduction about our esteemed keynote speaker, Dr. Ashish Mishra, sir, an accomplished academician, researcher, and mentor in the field of computer science and engineering. He is currently serving as a professor at Gyan Ganga Institute of Technology and Sciences, where he has dedicated more than 2 decades of service since November 2003. His long-standing commitment to education reflects his passion for teaching, research, and academic excellence. He holds a PhD in computer engineering from AISECT University, which reflects his strong academic foundation and continuous professional growth. He is also a senior member of IEEE, highlights his international recognition in the field of engineering and technology. His areas of expertise including image processing, data mining, and other advanced computational domains. As a researcher, he has contributed significantly to innovation, including involvement in patent work, showcasing his dedication to practical and impactful technological development. His academic profile reflects not only teaching excellence, but also a deep inclination toward research and innovation. In conclusion, Dr. Mishra stands as a symbol of dedication, innovation, and excellence in the field of computer science. His contribution continues to inspire students, researchers, and fellow academicians alike. We are truly honored to have such a distinguished scholar with us today. I now humbly invite Dr. Mishra sir to deliver the keynote address. Over to you, sir.
Mr. Sir, namaskar. आशीष सर, आपकी आवाज नहीं आ रही है। Sir, your mic is off. Ashish sir, your mic is off. You are not audible to us. Pooja,
Excuse me, sir. Dr. Mishra, sir, maybe your mic is off. You need to on the mic from there. Maybe there are some technical issues.
mhm.
Let's wait for 2 minutes, everyone. Dr. Mishra, sir, maybe you need to give
Sir?
permission to.
Hello?
Yes, sir. You're audible now. You're
हेलो,
मेरा माइक तो चालू है पर प्रॉब्लम क्या आ रहा है समझ में नहीं आ रहा
अभी आ रही है सर आपकी आवाज, तब आवाज नहीं आ रही थी आपकी.
आ गई आई एम
हाँ, अभी आ रही.
जी जी ठीक
Yes sir, you are audible
ओके
now.
ओके सर
And thank you sir for joining us.
ओके थैंक यू सो मच सर
I am really grateful to you that you have accepted our invitation immediately and now you are with us to deliver your keynote.
जी जी ठीक है ओके ओके गुड मॉर्निंग रिस्पेक्टेड डिग्निटरीज distinguished researchers and dear participants. It is my great honor to present on quantum machine learning, transforming artificial intelligence in the quantum era. So first of all, I congratulate to all the organizer of this wonderful conference. So before starting our talk, first we talk about quantum. The term quantum comes from quantum mechanics, which is a fundamental theory in physics. It describes how matter and energy behave at the atomic and subatomic level. Unlike classical physical systems at this level show unique behaviors such as uncertainty, discreteness, and probabilistic states. So in the simple term, we can say that quantum refer to the unusual behavior of very small particles. And what is quantum computers? Quantum computers are computational machines that uses the principle of quantum machine to perform calculations instead of classical bit 0 and 1, 0 or 1, it uses qubits, means quantum bits, which can exist in multiple states simultaneously. This allows quantum computer to potentially solve certain problems much faster than classical computer. So I will share my presentation.
आशीष सर अब विजिबल नहीं हो रहे हैं.
सर जस्ट सर मैं स्क्रीन शेयर कर रहा हूँ सर 1 मिनट सर
हाँ हाँ ओके ओके.
Okay, sir.
Sir, my presentation is visible?
No sir, not
No,
yet.
sir, it is not.
Yes.
Now it is visible, sir.
Just one minute. Wait. Yeah, it's visible.
Yes, sir. Yes, sir. It is.
So these are my contents. Introduction, history of quantum computing, various of classical AI, quantum machines as a computation tools, hybrid quantum machine learning architecture, comparative analysis, QML toolkit, sector impact, real world QML applications, the quantum ecosystem, the reality check, the origin, future research direction, synthesis, the future of computing, and conclusion. So,
Excuse me, sir.
yes, ma'am.
Your content is not visible. It only shows the desktop screenshot here.
No, it's visible.
No, sir. It's not.
This is visible.
No, sir. You
Yes.
need to click on that PPT, I guess.
Yes, ma'am. This is visible.
No, sir. You need to click on that new quantum era AI keynote presentation. You need to double click on that PPT so that it should be visible to us. Yeah, there.
Visible.
No, sir. Still not.
ये तो बिल्कुल क्लियर है जो हम कह रहे हैं सॉल्व हो
अगले प्रॉब्लम क्या है अभी? Visible क्यों नहीं हो रहा?
In fact, that page is visible.
Yes.
When you click on a particular point, that point is not highlighted. Only page is available.
वो भी वहाँ पे हमने सुना है लेकिन
एक मैं इसको रीशेयर करा नहीं यहाँ पे
Your PPT is not visible.
सर एक शो स्क्रीन नहीं में हाँ प्रेजेंट समथिंग एल्स ये ना नहीं विंडो पे है ना
ये एंटायर स्क्रीन कर दीजिए ना
हाँ इंटर स्क्रीन नहीं है ना
और कुछ
मैम विजिबल है
No, sir. Your screen is not shared with us.
शेयर तो हो रही है एंटायर स्क्रीन है
You need to share your screen with us, sir, first.
एक
Yeah.
एंटायर स्क्रीन कर दिए सेलेक्ट करिए शेयर करिए आप पीपीटी ओपन करिए
Yes, sir. Now it is showing PowerPoint presentation.
Yeah.
Okay. Yes, sir. Now it is visible. Completely visible. Yes, yes, sir.
Now this is visible. Next slide is also visible.
Yes, yes, sir. Now it is going on. Yeah.
Okay. So these are my contents, and in today's digital era, AI has become a transformative force across multiple domains such as healthcare, finance, cybersecurity, and smart system. From predicting disease to enabling autonomous vehicle, AI is driving innovation at the unprecedented scale. Over the past decade, AI has revolutionized field ranging from healthcare and finance to cybersecurity and intelligence system. We now have models that can diagnose disease, predict market, trend, and even generate human-like language. Now, quantum computing is a new technology that can solve many calculations at once. By combining AI with quantum computing, we get quantum machine learning, which can make system faster and more powerful. So we can discuss the journey of quantum science. So currently, numerous researchers are actively contributing to this field, enabling us to gain a deeper understanding of the history of quantum science. One by one, in this year, we can discuss. In 1980, Max Planck discovered energy quantum. So Max Planck introduced the idea that energy is not continuous but come in discrete packet called quanta. This was the birth of quantum mechanics, mechanics. It fundamentally changed physics by showing that nature at a small scale behave in a discrete, not continuous manner. In year 1921, Albert Einstein discovered photon theory. Albert Einstein explained the photoelectric effect and proposed that light consists of particles called photon. In year 1980, Richard Feynman discovered idea of quantum computation. So Richard Feynman and others proposed the quantum system could be used for computation. In 1996, Love Grover discovered Grover's algorithm. Love Grover developed an algorithm to search an unsorted database faster than classical methods. It uses quantum superposition, allowing multiple possibilities to be explored simultaneously. In year 2022, Anton Jellinger discovered quantum entanglement, made breakthrough using quantum entanglement. He was awarded, noted that he was awarded the Nobel Prize in Physics for his groundbreaking experiment on quantum entanglement. In this experiment, enabled advanced in quantum communication and quantum teleportation and supported the foundation for quantum network and cryptography. So we can understand the term, what is quantum entanglement? It is the important principle of quantum mechanics in which two or more particles are connected in such a way that if two particles are entangled, they do not behave as a separate entity, but rather as a single unified system. Measuring one particle instantly provides information about the other, regardless of the distance between them. In 2023, IBM Quantum Advanced developed of 1,000 plus qubit processors. In year 2022, Google Quantum AI progresses improvement in quantum error corrections and fault tolerant computing. In year 2025, quantum advanced expansion, hybrid quantum classical system applied in AI drug discovery and optimization. In 2026, quantum machine learning integration, practical adoption of quantum machine learning in real world AI system and cloud platform. So overall, this timeline shows the journey from theoretical foundation to practical and impactful quantum technology. In modern AI is incredibly powerful, but it is also approaching its computational limits. So this is the journey from 1980 to current year 2026. So this is the barrier of classical AI at a breaking point. So today I will discuss a critical challenge in modern AI, the limitation of classical AI system, and why we are approaching what can be described as a breaking point. So let's begin by looking at the left side of the visual. We see rapid AI growth. This represents the explosive advancement in AI technology over the last decade. From deep learning to generative model, AI systems are becoming increasingly powerful and widely adopted across industry. However, alongside the growth comes in a significant challenge. You can see that the next part is high dimensional data. So modern AI model must process enormous data sets with thousands, sometimes millions of features. While this richness enable better predictions, it also introduces complexity that is difficult to manage using traditional computation approach. In addition, we face a complex optimization requirement. So training AI model involve finding optimal parameters in vast search spaces. As model grow deeper and more complex, optimization become increasingly difficult, often requiring sophisticated algorithm and enormous computational effort. Now let's move forward the center of the diagram, which illustrates a narrowing funnel. This represents a bottleneck, a point where classical AI systems begin to struggle under increasing demands. As we push more data and complexity into this system, they encounter fundamental constraints. On the right side, we see the consequence of this bottleneck four major barriers. The first one is the high computational cost. Deep learning model require massive computational resources. Training a state-of-the-art model can take days or even weeks on powerful hardware like GPU or cluster. This is not only expensive but also limits accessibility for smaller organization and researchers. The next part shows slow processing. So classical computing relies on sequential processing even with parallelism. Many tasks, especially those involving large scale, multi-dimensional data, become slow and insufficient. This limits real-time decision-making capabilities. The next part is the energy consumption. So training large AI model consumes a vast amount of energy. This raises concerns not only about cost but also about environmental sustainability. As model scale, energy demand increases dramatically, making current approaches less visible in the long term. And the last part is the scaling issue. Finally, we encounter scalability challenge as data size, as complexity grow exponentially, performance improvements begin to plateau. In other words, adding more data or computational power does not always lead to proportional gain in performance. So in the so the question arises, how do we overcome this limitation? So this is where emerging paradigms such as quantum computing and quantum machine learning come into the picture. These approaches aim to fundamentally rethink computation, enabling us to process high-dimensional data more efficiently and solve complex optimization problems beyond classical capabilities. To summarize this slide, so AI is growing rapidly, driven by data and complexity. Classical system face a bottleneck due to computational processing, energy, and scalability constraint. These challenges indicate a breaking point. New paradigms are required to push AI beyond current limits. So classical AI is very useful, but it has some limitations. It needs a lot of data, high computing power, and time to solve complex problems. Also, optimization and scalability are major challenges, and it consumes a lot of energy. So this leads to three important observations. So first, the gap between data exploration and computation capabilities. So we are generating massive amount of data, but processing it efficiently remain a challenge. Second is the conflict between model complexity and efficiency. As AI models become deeper and more sophisticated, they require enormous computational resources, time, and energy. Third is the shift from classical computing to emerging model. So we are now questioning whether traditional computing architectures are sufficient for the future. So this brings us a fundamental question. Can quantum computing redefine the future of artificial intelligence? Yes, quantum computing has the potential to redefine AI by enabling new computational capabilities such as solving complex optimization problems and modeling high-dimensional data that are beyond classical limits. However, its impact will emerge through a hybrid quantum classical paradigms where quantum systems enhance rather than replace traditional AI methods. So, these are barriers. My slide is visible?
Yes, sir, it is. Yes, sir, it is visible.
Yeah. So what is quantum computing? So when combined with AI, it leads to quantum machine learning, a field that has potential to transfer how we design intelligent system. Quantum computing, which is based on the principle of quantum mechanics. Classical bit either 0 or 1, or quantum bit means qubit 0, 1, or both simultaneously. A qubit represents a probability distribution of a state, enabling richer information encoding. So For example, a classical system checks one possibility at a time, whereas a quantum system can represent multiple possibilities simultaneously. So modern AI systems are reaching the limit of classical computing as data continues to grow exponentially and model become more complex. Classical computational systems struggle to keep pace. This creates a serious bottlenecks in terms of processing speed, scalability, energy consumption, and optimization efficiency. The next, so you can show the see the diagram of this difference, the classical bits and quantum qubits. The next slides, the quantum machine as a computational tool. So quantum machine is not just a theory of physics, it is becoming a powerful computational framework. Unlike classical computers that process information step by step, quantum systems use qubits and unique principles like superposition and entanglement to solve complex problems more efficiently. This slide highlights three pillars of quantum computing power. First one is the superposition. Based on the quantum superposition, a qubit can exist in multiple states, 0 and 1 at the same time. So instead of checking one possibility at a time, the system can explore many possibilities simultaneously. This greatly increases the ability to handle complex, high-dimensional data. So, for example, in searching a large database, so classical uses the sequential search and quantum uses the multiple entries simultaneously. The second is the entanglement. So, based on the quantum entanglement, so qubits become interconnected. So, the state of one instantly affect another. So, enabling a strong correlation between variables, very useful in pattern recognition, optimization problems, quantum communication. So, for example, in a complex optimization problem, changing one variable can immediately affect related variable, enabling faster convergence to optimal solution. Our last pillar is the quantum parallelism, a direct consequence of superposition and entanglement. A quantum computer can perform many computations at the same time rather than step by step. This is critical for solving AI optimization problem, large search spaces, complex simulations. So in a parallel search in the large database, for example, if we search parallel search in the large database, so imagine you have a database of 1 million entries and you want to find a specific item. So see in the bottom diagram, in a classical computing, left path at a time, explore one route, may hit a dead end, slow for complex problem. So sequential processing find one dead end, and the C quantum computing right blue maze. So explore all possible paths simultaneously using superposition, find the correct path much faster. So this slide illustrates why quantum computing is so powerful. First, superposition allows qubit to exist in multiple states simultaneously. Second, entanglement connects qubit in a way that change in one instant influence another. Together, this enables quantum parallelism where many computations are performed at once. The maze example clearly shows the difference. Classical computer try one path at a time, while quantum system explore all paths simultaneously, dramatically improving efficiency. So quantum computing does not just compute faster, it thinks differently, exploring possibilities that classical system cannot. So this is the description. The next slide shows that the bridging the gap, the hybrid quantum machine learning architecture. So now let us understand how quantum machine learning is practically implemented using a hybrid architecture. where classical and quantum system were together. So in section 1, this architecture does not replace classical computer. Instead, it intelligently combines classical computing with quantum processing to solve complex machine learning problems more efficiently. The section 2, input massive data sets. So we begin with a massive real world data sets such as images, financial records, or medical data. Handling such a large volume of data directly on quantum system is not feasible today. So we rely on classical system initially. The section in the section 3, the classical system is pre-processing. The classical system play a crucial role in managing input and output operation, cleaning and organizing the data, performing feature extraction and normalization. This ensures that only the most relevant and structured data is sent to quantum system. In section 4, quantum circuit means core learning. Next, the process data is fed into the quantum circuit, which is the core innovation. Here, quantum computing enables solving complex optimization problems, performing advanced pattern recognitions, leveraging quantum superposition and entanglement. This allows the system to explore multiple solutions simultaneously, significantly improve learning efficiency. In the section 5, hybrid feedback loop. So one important aspect is the iterative feedback loop. The quantum circuit produces results. These results are evaluated by the classical system. Parameters are updated and sent back to the quantum circuit. This continues until the model achieves optimal performance. Section 6, the output is a redefined deployment. So finally, the system produces a redefined and optimized output, which can be deployed in a real-world applications with improved accuracy and efficiency. So we can explain with a simple example, medical diagnosis like cancer detection. A hospital collects thousands of medical images. The classical system reprocesses these images, removing noise and extracting features. The quantum system then analyzes complex patterns in the data to detect early stage cancer. Through iterative optimization, the system improves diagnostic accuracy. The final output is a highly accurate and efficient diagnostic model. To summarize, the hybrid quantum machine learning bridges the gap between classical reliability and quantum computational power, making advanced AI solution faster and more effective. So this is the comparative analysis of classical AI and quantum AI. So in this slide, we compare classical AI and quantum AI across key dimensions to understand where each approaches excel and where quantum system offer potential advantages. So first one is the computing unit. So classical AI operate on bits which exist as either 0 or 1. In contrast, quantum AI uses qubits which can exist in both 0 and 1 simultaneously due to the superposition. This is the fundamental reason behind the power of quantum computing. The second is the processing speed. So classical system process take mostly sequentially with a limited parallelism, and quantum system enable massive parallelism allowing multiple computation at once. So this lead to potentially significant speed improvement in complex problem. Third is the data handling. So classical AI is highly effective for moderate size dataset, and quantum AI is better suited for high dimensional data where patterns are extremely complex. So this is especially useful in domain like geometric and financial modeling. The fourth is the optimization capability. So optimization is often time consuming in classical system, especially for large scale problem. And quantum AI can provide exponentially faster optimization in certain cases. This makes it highly promising for solving NP-hard and combinational problem. And the next is the scalability. So classical systems are limited by hardware constraints such as heat generation and chip density. and quantum system theoretically offer exponentially scalability. So, however, practical scalability is still under research. The next is the hardware requirements. So, classical AI run on conventional silicon chip, and quantum AI require highly specialized quantum hardware such as superconducting circuit on trapped ion. This makes quantum system currently expensive and less accessible. And last is the maturity level. So classical AI is fully mature, widely deployed, and industry proven. And quantum AI is still emerging, experimental, and often used in hybrid model. To conclude, classical AI is reliable and mature, while quantum AI offer transformative potential, especially for solving highly complex and large-scale problems. The future lies in hybrid integration of both approaches. The next slide shows the QML toolkits updating standard algorithms. So in this slide, we explore how quantum machine learning enhance standard machine learning algorithm, creating a powerful toolkit for solving complex problems more efficiently. So in the first one is the classification. So classification uses quantum support vector machine. So let us begin with classification. In classical machine learning, support vector machine work well for many problems, but they struggle when data become highly complex and non-linear. The quantum support vector machine address this by mapping data into a high-dimensional quantum feature space, enabling better separation of complex data classes. This improves classification accuracy for difficult data sets. So, for example, consider spam email detection. So, classical support vector machine may struggle with a substable pattern in text, and then quantum support vector machine can map this pattern into higher dimensional space, so better separation between spam and non-spam emails. Next algorithm is the feature extraction. So feature extraction uses quantum principal component analysis. So next is the feature extraction, which is a question for reducing data complexity. Quantum principal component analysis. So it is efficiently processes large and high dimensional data sets, extract the most important underlying features faster than classical principal component analysis in certain cases. So, with in this example, in medical imaging, thousands of features exist in MRI or CT scan. So, quantum principal component analysis identifies the most critical features faster and more accurate disease detection. The next is the search operation. So we use the Grover algorithms. So search problems are very common in AI. Grover algorithms provide a quadratic speed up for searching unsorted databases, significant improvement over classical linear search. So, for example, in imaging, searching a large database of potential patient record, so classical search checks one by one, and Grover algorithm reduce the number of required searches dramatically, so faster retrieval of critical information. And last is the optimization and training. So finally, we look at the optimization and model training, which are computationally intensive. So they are uses variational quantum algorithms and quantum neural network. So these uses parameterized quantum circuit, work in hybrid classical quantum loop, accelerate training and optimization process. So in this example, in financial portfolio optimization, the classical method take longer for large portfolio, and variation quantum algorithms can explore multiple portfolio configuration simultaneously. So faster identification of optimal investment strategy. To summarize, the quantum machine learning toolkit enhance the traditional machine learning by introducing quantum power improvement in classification, feature extraction, search and optimization, enabling faster and more efficient solution for complex real-world problem. So next is the sector impact in real-world quantum machine learning application. So in this slide, we explore how quantum machine learning is transforming multiple real-world sectors, solving problems that are extremely challenging for classical system. So at the center, we have quantum machine learning acting as a powerful engine that connects the enhanced various industry through advanced computation and optimization. So first is the supply chain optimization. So first application is the supply chain sector. So QML help in optimizing logistic and routing, mapping global resources efficiently, enabling real-time decision making. So this is especially useful for large-scale dynamic system. So consider a global delivery company. So classical system struggle with dynamic route changes, or QML can evaluate multiple routing possibilities simultaneously. So it's a faster delivery and reduce operational costs. Next application is drug discovery and healthcare. In healthcare, QML accelerate molecular simulation, protein interaction modeling, drug discovery process. These tasks are computationally expensive for classical computer. So, for example, in cancer search, QML can simulate how different drug molecules interact with cancer cell. So it's a faster identification of effective treatment. Next application is a financial modeling. So in finance, QML help processes highly volatile market data, risk analysis and prediction, portfolio optimization, fraud detection. So quantum system can analyze many market scenarios simultaneously. So a bank can use QML to analyze thousands of investment combinations. So optimal portfolio selection with a reduced risk. The next is the climate modeling. So climate systems are highly complex and evolved, high dimensional environmental data, non-linear interactions. QML enables more accurate simulation than classical method in certain cases. So for example, in predicting climate change patterns, so better disaster management and policy planning. And the last is the cybersecurity. In cybersecurity, QML supports advanced cryptographic technique, secure communication system, protection against classical hacking methods. So it also contributes to post-quantum security strategies. So for instance, developing quantum sector in encryption system. So it gives the stronger protection of sensitive data. To conclude this slide, so quantum machine learning is not just theoretical, it is the already showing transformative potential across industries from healthcare to finance and beyond. So why combining quantum computing with AI? So because it gives the faster computation for large data set, improve optimization algorithm, enhance pattern capabilities, potential acceleration of machine learning training. The next slide shows the quantum ecosystem, drivers of innovation. So in this slide, we shift our focus from application to ecosystem that is driving innovation in quantum technologies and quantum machine. Unlike traditional technologies, quantum computing is not evolving in isolation. It is being shaped by a powerful combination, corporate platforms, academic research, government and private investment. So together, these elements from what we call the quantum ecosystem. As you can see, the slide is divided into two major parts: corporate platform and collaborative movement. So let's first understand the role of major industry players. So first is the corporate platform. So first is the IBM Quantum. So let's start with IBM Quantum. IBM has played a pioneering role of making quantum computing accessible through the cloud. Instead of requiring expensive hardware, User can access a real quantum process remotely. So it is so it's a hands-on experiments. So for example, for instance, a student or researcher can log into IBM platform and run quantum circuits, test QML algorithm, analyze real quantum noise. This has significantly accelerated learning and search globally. The second is the global quantum AI. So next we have global quantum AI. So next we have global quantum AI. Google is focused on achieving what is known as quantum advance, where quantum computer outperform classical ones in a specific task. So it gives the advanced algorithm development, high performance quantum processors. So for example, a well-known milestone is when Google demonstrated quantum supremacy for a specific competition task, showing that a quantum processor could solve a problem much faster than a classical supercomputer. In QML, this translates into faster optimization learning capabilities. And the last is the Microsoft Azure Quantum. So it's a building a comprehensive ecosystem. This focuses not just hardware, but also development tools, programming environments, simulation platforms, and end-to-end quantum development ecosystem. For example, developer can write quantum programs, simulate them, deploy hybrid quantum classical model. This is especially used for QML applications where classical and quantum systems work together. And the second part is the collaborative. So in the first is the academic search. Now let us move to academic search, which form the foundation of the innovation. Universities across the world are actively working on quantum algorithms, quantum machine learning model, theoretical advancement, knowledge creation, innovation pipeline. For example, for instance, researchers are developing quantum neural network, variation quantum circuits. So these are the essential building block for future QML system. Many breakthrough a quantum computing actually originate from the academic lab before reaching industry. And second is the public-private capital. In public-private capital, quantum technology require massive investment due to expensive infrastructure, long research cycle, high technical complexity, government plus industry collaboration. So government funds national quantum missions while private companies investment in research and development. So for example, government grants support university research, corporate converts research into real world products. So this collaboration accelerates the transition from lab experiment to practical application. As important point to understand is that these components do not work independently. They are highly interconnected. Interconnected. Corporation provides platform, academia, development algorithm, government and investor providing funding. This synergy creates a self-reinforcing cycle of innovation. To conclude, the quantum ecosystem is the backbone of all advancement in quantum machine learning and quantum computing. Without industry platform, academic research, financial support. So in simple terms, innovation in QML is not driven by a single entity. It is the result of global collaborative efforts. As a researcher and practitioners, understanding this ecosystem help us identify where to contribute, how to collaborate, and how to leverage available platform effectively. So this future of quantum technology depend not just on breakthrough, but on how well this ecosystem continue to evolve and collaborate. The next slide shows the reality check current hurdles in quantum AI. So up to this point, we have discussed the immense potential and application of quantum machine learning and quantum AI. However, it is especially important to take a reality check. This slide highlights the current challenges and limitations that prevent quantum AI from achieving full-scale real-world deployment. So, in the simple way, while the promising revolutionary, the technology is still evolving. As shown in the slide, there are 6 major hurdles. First is the hardware limitation, qubit instability, error correction challenges, limited algorithms, infrastructure cost, the skill gap. So, in the hardware limitations, so first, quantum computers are still in their early stages, often referred to as the noisy intermediate scale quantum. So, it's the current system provide the limited number of qubits, high noise levels, short coherence times. For example, a classical computer can easily handle millions of bits, but today's quantum computer typically operate with only 10 to a few hundred qubits. This is severely restrict the complexity of problem we can solve using a QML today. The second is the QML intensivity. So next is the qubit instability, also known as decoherence. So qubits are extremely sensitive to temperature, electromagnetic interference, environmental noise. So even a small disturbance can cause loss of quantum information. So for example, imagine trying to balance a pencil on the tip. Any slight disturbance causes it to fall. Similarly, qubits lose their quantum state very quickly, leading to computational error. This instability is one of the biggest challenges in building reliable quantum system. The third is the error correction. So closely related to instability is the issue of error correction. In classical system, error correction is relatively straightforward, but in quantum system, it is extremely complex due to the nature of quantum state. To correct errors, we need multiple physics qubits to represent a single logical qubit. This increases the system complexity significantly. To maintain one stable logic qubit, we may need dozens or even hundreds of physical qubits. This makes scaling quantum system very challenging. The next is the limited algorithm. So it's a lack of a mature quantum algorithm. While theoretical search is extensive, practical and scalable QML algorithms are still limited. So many algorithms work only for a specific problem, are not yet optimized for real world deployment. So we have promising model like quantum support vector machine, variation quantum circuit, but they are still largely experimental and not widely used industry. And the next is the infrastructure cost. So quantum computing require extremely specialized hardware. This include advanced shielding mechanism, high precision control electronics. So maintaining a quantum computer often require temperature colder than outer space. This makes installation expensive, maintain highly complex. As a result, only large organization and research lab can currently offer the system. And the last is the skill gap. So quantum AI is inherently interdisciplinary, requiring knowledge of quantum physics, machine learning, mathematics, programming. So there is a shortage of professionals who possess expertise in all these areas. So a machine learning engineer may not understand quantum machines, and physics may not be skilled in AI development. So this gap show down research, development, and adoption of QML technologies. So it is important to note that these challenges are interconnected. For example, better hardware reduces error. Improved algorithm require better hardware. Skilled professionals are needed to solve both. So progresses in quantum AI depends on addressing all these challenges simultaneously. So final conclude, while quantum AI holds transformative potential, it is still in the development phase. So these challenges remind us we are in the beginning of the quantum journey. significant research and innovations are still required. However, just like classical computing evolved over decades, quantum computing is expected to mature with time. As a researcher, this presents a valuable opportunity, not just to use quantum technology, but to help build it. The future of quantum AI depends on how effectively we overcome these challenges today. The next slide is the horizon future research directions. So after understanding the current challenges in quantum AI, the next logical question is, where do we go from here? This slide presents the future research roadmap for quantum machine learning. It is structured as a step-by-step progression showing how advancement in different areas will collectively leads us toward practical and scalable quantum AI system. As we can see, there are 5 key steps: scalable hardware, quantum data encoding, noise reduction, practical hybrid models, interdisciplinary collaboration. So let us discuss each step in detail. So first is the scalable hardware. Firstly, scalable hardware. Currently, quantum systems are limited in size and stability. To unlock real-world QML application, we need to build larger and more reliable quantum processor. Focuses area includes increasing qubit count, improving qubit coherence, enhancing system isolation. So today devices may have a few hundred qubits, but future system may require thousands or even millions of stable qubits to solve complex AI problems like large-scale optimization or deep learning. Second step is the quantum data encoding. So one of this biggest challenge is converting classical data into quantum state effectively. So this process often called quantum feature mapping. So the key challenges is classical data sets are massive, quantum systems have limited qubit. So imagine trying to input a high resolution image into quantum efficient encoding technique are required so that improved features are preserved, computational advantage is maintained. Improving encoding method is essential for making QML practicals. The next step is noise reduction. So next, as discussed earlier, quantum systems are highly sensitive to environmental disturbance. So future research focuses on fault tolerant quantum computing, advanced error correction techniques. So if a quantum system is performing a classical classification task, even small noise can disturb the output. So by reducing noise, accuracy improves, reliability increases. This step is critical for transforming from experimental setup to real-world deployment. The fourth step is the development of practical hybrid model. Instead of replacing classical system entirely, the future lies in the combining classical computing, quantum processing unit. So this is known as hybrid quantum classical computing. So in a QML pipeline, the classical system handle data pre-processing, quantum system perform optimization of feature transformation. This approach allows us to leverage strength of both systems, overcome current hardware limitations. So many current QML model, such as variational circuits, already follow the hybrid approach. The next, so finally, the interdisciplinary collaboration step is the interdisciplinary collaboration. So quantum AI is not confined to a single field. It requires expertise from mathematics, computer science, quantum physics, engineering. So innovation happens at the intersection of these disciplines. So designing a new QML algorithm may require mathematical modeling, quantum circuit design, machine learning optimization technique. No single domain expert can do it alone. So collaboration is essential for accelerating breakthrough. So these steps are not independent. They are deeply interconnected. For example, better hardware enables better algorithm, improve encoding, enhance model performance, collaboration accelerate all other steps. This roadmap represent a coordinated research efforts, not isolated progresses. So, conclude the future of quantum machine learning depends on advancement across multiple dimensions. This slide provide a clear vision of build scalable system, improve data handling, reduce noise, develop hybrid model, encourage collaboration. If these directions are successfully pursued, we can move from experimental quantum AI to real-world transformative application. The journey is challenging, but the potential impact is enormous. The future of PML is not just about faster computation. It is about redefining how we solve complex problem. Now move to next slide. So now we arrive the final and most important part of this presentation, the synthesis of everything we have discussed. This slide captures the big picture where we are today, what limitations we face, and how quantum machine learning is shaping the future of computing. At the center, you can see the next generation of intelligent system, which represent the convergence of classical and quantum paradigms. This diagram shows two overlapping domains. See, on the left hand, classical limits, and the right hand, the quantum potential. At the middle lies the future intelligence system powered by hybrid quantum classical approaches. We are not replacing classical computing. We are enhancing it with quantum capabilities. So let us first understand the limitation of classical computing. Classical systems have driven AI and machine learning for decades, but they face challenges such as high computational cost, exponential growth in the complexity, optimization bottleneck. So consider training a deep neural network with billions of parameters, even with GPU. This requires enormous time and energy. Similarly, problems like drug discovery, climate simulation, large-scale optimization become computationally infeasible as complexity increases. So these are what we call classical limit. In the quantum potential, on the other side, we have quantum potential. Quantum computing introduce superposition, entanglement, quantum parallelism. This enable us to process multiple possibilities simultaneously. So in optimization problem, instead of evaluating solution one by one, a quantum system can explore many configurations at the same time. This opens the door to faster learning algorithm, more accurate simulation, efficient handling of high dimensional data. However, as we discussed earlier, this potential is still being realized. The most important part of the slide is the center, the next generation of the intelligence system. This represents hybrid quantum classical system. Instead of waiting for fully mature quantum computer, researchers are combining classical AI model, quantum computing modules. So in a quantum machine learning pipeline, classical system handle data preprocessing and feature extraction, and quantum system perform optimization of complex pattern analysis. This hybrid approach maximizes current capabilities, minimizing limitations, accelerate practical adoption. So this is the realistic path forward. So now let us interpret the three key insights provided at the bottom of the slide. So insight one, QML is the emergent paradigms, the challenges, the speed and optimization limit of classical computing. So, quantum computing is not just faster; it changes how problems are solved. Then, inside two, so despite current limitation like hardware constraint and decoherence, hybrid systems are rapidly advancing. So, even with challenges, progresses in happening through integration, not replacement. In the inside three, the global investment and interdisciplinary research will transition QML from experimental to fundamental. With strong collaboration and funding, QML will become a core technology, just like classical AI today. So, so finally, we can say that quantum technology will shape the future of AI. This means AI system will become more powerful, complex problem will become solvable, entire industry will be transformed. So we are not just improving computing, we are redefining intelligence itself. So finally conclude this presentation. So classical computing has brought us this for quantum computing is pushing the boundaries further, and together they will define the future of intelligent system. So quantum machine learning stands at this interaction, acting as a bridge between today's capabilities and tomorrow's possibilities. As researchers, educators, and practitioners, this is an exciting time, not just to observe this transformation, but to actively contribute to it. The future of computing is not classical or quantum, it is the intelligent future of both. These are the references. Thank you.
Thank you, sir. For those profound and insightful thoughts, you have truly set a scholarly tone for the rest of the day. Now, moving ahead, it is my profound privilege to propose the vote of thanks on this auspicious occasion on the inaugural session and keynote session of the one-day National E-Conference on From Bits to Qubit, Quantum Computing and Beyond. First and foremost, I express my deepest sense of gratitude to our honorable chief guest, Dr. Ravinder Kumar Singhal, sir, and respected chairperson, Dr. S.C. Gulhane, sir, for his constant guidance, visionary leadership, and for sharing his valuable presidential remarks that added great depth of the session. I express my sincere and heartfelt gratitude to our esteemed keynote speaker, Dr. Mishra, sir, for delivering such an inspiring and knowledgeable, enriching address. Your vision, your valuable insight into advanced domain of computer science have greatly enhanced our understanding and inspired all the participants. We are truly grateful for your time, guidance, and for sharing your expertise with us. I am highly grateful to our respected director, Dr. Praveen Joshi, sir, for his continuous support and encouragement, and for honoring the chief guest with his thoughtful words of appreciation. My heartfelt thanks to our esteemed principal, Dr. Urmila Jabir Madam, for her inspiring welcome address and for being a pillar of strength in organizing this conference successfully. I would also like to extend my thanks to all the participants for their attentive presence and enthusiastic involvement, which made this session meaningful and interactive. Lastly, I sincerely appreciate the organizing team for their dedicated efforts in ensuring and smooth conduct of this session. With this, we conclude the keynote session and now move forward to the next segment of this conference, the continuation of the program. I request Mrs. Hafita Madam to kindly take over and proceed with plenary session 1. I now take your leave. Thank you and have a good day.
Sir, really, thank you very much. It was really very informative, educative, and enlightening keynote address. We are really very happy. It was pleasure listening to you and watching your presentation. Thank you, sir. Thank you very much. Please move ahead.
already
Yes, please continue.
Thank you, Ms. Pooja ma'am, respected dignitaries, esteemed resource person, honorable chairperson, and dear participants. Now we proceed to plenary session 1 of today's conference. I, Ms. Harshita Nagpure, Assistant Professor from the Department of Computer Science at Dr. S.C. Gulhane, Prerna College of Commerce, Science and Arts, feel highly privileged to be the host for the first plenary session of this national conference. The theme of this session is Decoding the Brain, the Role of Machine Learning in Neurological Disorders. This topic highlights the fascinating intersection of neuroscience, machine learning, and artificial intelligence. With the help of advanced computational techniques, researchers are now able to analyze complex brain data, detect meaningful patterns, and assist in the early diagnosis and treatment of neurological disorders such as Alzheimer's disease, Parkinson's disease, epilepsy, and stroke. This session aims to further explore the dynamic intersection between machine learning and artificial intelligence, highlighting their transformative role in advancing modern research and technological innovation. We are truly honored to have with us our esteemed resource person whose expertise and insights will enrich our understanding of this fascinating field. Our speaker for this session is Professor Dr. Ishwar Baidari sir, whose academic insights and vision will guide the discourse of this session. It is my privilege to present a brief introduction of our distinguished resource person. We are honored to introduce Professor Dr. Ishwar Baidari sir, a distinguished academician and researcher in the field of computer science. Dr. Baidari is currently serving as a professor in the PG Department of Studies in Computer Science at Karnataka University, Dharwad, Karnataka. He holds a PhD, MCA and BSc from Karnataka University and has made significant contributions to teaching, research and academic administration. With more than 2 decades of teaching experience, he began his academic career as a guest faculty at Karnataka University in 2001. He later served as a lecturer at the PG Department of Studies in Computer Science at Kevampu University, Shimoga, before returning to Karnataka University, where he continues his academic service. His areas of specialization include algorithms, data mining, and machine learning, which are key domains driving modern computing and data analytics. He has actively contributed to research and has published around 25 research papers in various national and international journals and conferences. Apart from teaching and research, he has played an important role in academic governance. He has served as a Board of Studies BOS member in several universities, including Karnataka University, Kevampu University, and Tumkur University, and as a Board of Examiners BOE member for institutions such as Bangalore University and Gulhane University. In addition, he has contributed as a technical member to the Department of Panchayat Raj and Rural Development, Government of Karnataka. He has also actively participated in international academic forums, including the Science and Information Conference 2014 held in London and an international conference at Indian Institute of Technology, Kanpur in 2019. We feel privileged to have such a distinguished scholar among us today, and we look forward to his insights enriching our understanding of the theme Decoding the Brain, the Role of Machine Learning in Neurological Disorders. Additionally, it is my honor to introduce our respected chairperson, Professor Dr. Ravikant Jugele sir. He is an associate professor at the head of the Department of Computer Science at Sri Shivaji Science College, Nagpur. With his vast academic experience and dedication to higher education, he has made significant contributions to the field of computer science. He is also serving as the chairman of the Board of Studies in Computer Science at Rashtrasant Tukaroji Maharaj Nagpur University. Under his able guidance, more than 10 scholars have successfully completed their PhD, and many other research scholars have been awarded their degrees under his supervision. His commitment to research, academic excellence, and mentorship has greatly benefited students and the academic community. We are truly honored to have such a distinguished academician and mentor as the chairperson for this session. Without further delay, I now humbly invite Professor Dr. Ishwar Vaidari sir to deliver his plenary talk. Over to you, sir.
Sir,
Thank you,
welcome, sir.
madam.
Dr. Ishwar,
Thank you, sir.
I heartily welcome you and thank you for accepting the invitation immediately. And it's pleasure meeting you here, although it's online. Thank you, sir. Thank you very much.
sir. Thank you very much. Because of you, I am part of this conference today. And I also thank you, madam, for your kind introduction about my resume. So once again, greeting professors, those who are already presenting in this session. Let me begin with my session, as madam already introduced about the title of this lecture. That is the how the machine learning algorithms are transforming neurology. Actually, the neurology means there are several mental disorders currently we are noticing. There is one of them, Alzheimer, and schizophrenia, autism spectrum disorder, and many more. In my first slide, neurological disorders are leading to cause of disability and the second leading cause of death worldwide. These are the some medical terminology is involved here, but I'm going to present the topic which we are currently doing research on it, and also we have got the good number of the good results. How the neurological disorders can be noticed in the early stage, and also it can be diagnosed, and also that right diagnosis can lead to the correct right prescription of the medicine and overcome the problems. So can you see my slides?
No,
I
sir.
hope all of you can.
Yes. Now it is visible.
Now it's visible.
Yes.
If it is disappear, kindly let me know, ma'am.
Blur.
Content
So your
is blurred.
contents are blur. Yes.
Yes, sir. Now it's okay.
Okay.
Now it's okay.
Yes, sir.
Okay. Sorry for the interruption. The main core problem in this area is it's a late diagnosis, misdiagnosis due to overlapping symptoms and a lack of objective tools for early detection. For instance, I will take the current problem, which is autism spectrum disorder, because among 2% of the kids are suffering of this autism spectrum disorder. These symptoms noticed at the early stage, means early stage in the year of the kid at the age of 3 years, we start noticing the symptoms of the autism spectrum disorder. Due to lack of awarenesses about these diseases, many of the parents are neglecting those symptoms. So it becomes the major issue or the problem while overcoming such issues at the later stage. But in the overall, there are many factors. The causes for these mental disorders. It may be hereditary. It may be the lifestyle of the nowadays lifestyle of the people, and many more. I'm not going to go in deep about the causes of these mental disorders because we are not a clinical diagnosis. Ours is a machine learning algorithm. So whatever the clinical data publicly available or the publicly published, those data sets, we first fetch those data sets and we apply our algorithms and we find and compare our accuracy with the clinically diagnosed methods. Then we can have the well-proven external validation techniques, so we can finally arrive at the final stage and make the conclusion on that particular disorder. The challenges at the clinical level, overlapping symptoms between diseases, Alzheimer and maybe frontotemporal dementia. There are several mental disorders. I took the sum of them. For example, as I said, autism spectrum disorder and schizophrenia. There are many overlapping symptoms we can notice, but the doctor faces a challenge here to come to the arrival at the right time with whether to bifurcate both the disorders, whether it is schizophrenia or whether it is autism spectrum disorder. Brain scans that are invisible to the naked eye, because when the person or the kid approach to the doctor, they first recommend for the MRI scanning and other diagnosis process, and the vast amount of complex data. It may be imaging data, because once we got the MRI screens, there is some pattern. That pattern which the doctor can make the conclusion that is also one of the main challenges the doctor can face, the genetic problem. And the sensors. The sensors are that is early stage of the normal motor stage of the kid. That is how his sense organs are working it properly or not, whether he can speak it, whether he can pronounce the one word or the sentences or the single letter. Those are the early level of screening of the particular kid that are impossible to integrate manually. Now we comes to the ML solutions. ML algorithms excel at finding hidden patterns in high dimensional data. For example, there may be publicly available data, maybe more than 5,000 genes we can fetch. That's the one challenge is here, processing such a huge high dimensional data and fetching our required the pattern. It is a challenging task. they provide a second opinion. But our diagnosis and our result, it is a decision support system. It's like a decision support system, like a second opinion. Actually, in the real time, how do we take the second? Once we approach any doctor, after the first doctor diagnosis, we have in a mind that why can't we take a second opinion in this case? Similarly, here our ML solution is a second opinion for the doctor, so he can arrive or make the right diagnosis of the particular disorder. Machine learning, these are the basic things which we are classifying different classifying algorithms.
Sir, you are not audible. I think some issue is there, technical issue. Maybe there is some network issue. We will continue in 2 minutes. Please bear with us.
Am I audible now, ma'am?
Yes, sir, you are audible.
Due to some technical issue here.
Yes.
My screen is visible.
No, sir, your screen is not visible now.
Now?
Yes, now it is visible.
Okay. Okay. Because we are not a doctors, so we are the engineers or the computer scientists. So because we no need to know some core medical terminologies here, because our work start from once we got the genes or the medical images. Our work start from that stage. Okay. This is the entire flow chart for it may be begin with processing the data and taking the exact features of the data, feature selection, extraction that we can see here. That is our training set. So using that training set, we can train our model. This is our challenging task here, feature extraction and the feature selection. So there are many methods, already existing method, but what we are defining our own method, and we have already defined the own method, and we tested it also, and we got the good results. Once we train the model, next comes the test data. This test data means the new patient comes with that noticeable symptoms, because we cannot arrive the decision at this stage. So, but first we collect is required data. So whatever the model we have trained here, that we provide these data to that trained model. Based on the accuracy or the output, we can provide this information to the doctor. As I said earlier, this is our second opinion. It is a second opinion to the doctor. Okay. What is the machine learning? It is a very basic thing. For example, we have a data set here. Maybe it is a label data. So I can convince more to anyone. So simply any layman can understand what is a machine learning. See, these are the label data, apple, orange, apple, it may be many more. That is once we trained, this is our model, the machine algorithm. Once we train the classifier or the machine learning algorithm, then based on the training data set, it can predict. This is test data. Test data in the sense whether if I trained my model with these data set like some fruits, apple, orange, and other thing, and I can provide this training data set to different fruit. So it can predict whether the given fruits are apple or orange or apple. If I got the right information based on the test data, so I can make a conclusion that my model which I have already trained, that is working properly. As I already shown in the flowchart, that is the feature selection and extraction. This is our, we need to contribute more here. The computer scientist or the computer science engineers has to contribute here. Identify the most important variable from the thousands of possibilities, not thousand, it may go beyond thousand. Reduces the unwanted features and focus on what truly matters. For example, deep learning. It is a neural network. There are many algorithms in the neural network like CNN, conventional neural network. It is also one of the classifier. It is well proven classifier or the machine learning algorithm which we have already tested. Solving the diagnostic dilemma, the problem. Many neurodegenerative diseases like FTD and Alzheimer's present with the similar symptoms. Not only these two disorders, as I said, it may be autism spectrum disorder and the schizophrenia. Present with the similar symptoms. There may be overlapping symptoms, but at that stage, doctor is in dilemma that whether he can diagnose the particular person or the kid is schizophrenia or autism spectrum disorder. But our results surely, I'm 100% sure that surely gives a second opinion to the doctor to arrive at the right opinion. Multi-class classification. New ML frameworks like the lifespan tree can differentiate between 6 different types of dementia, simultaneously using the MRI data, overperforming traditional methods like SVM. SVM is one of the classifier in the machine learning algorithm. Actually, we cannot depend on only on the hereditary set of data like genes. We can also depend on the MRI data set. That is, once we got the MRI screens, we need to process it and acquire the required features from that image or the pattern. And we can also compare that pattern with the already existing data set, whether both will go in parallel or not. And the biomarkers. ML models identify patterns of brain atrophy specific to each disease, providing an objective radiological marker. Means at the radiology doctors, they can mark based on their early information. If they get the right pattern, they can write their remarks at the first stage. Once the radiological process is over, the radiological doctor will take the decision on it. Then it will go to the doctor. Because what we are doing currently on the gene data side, these are the different genes having the different values at the For example, BARX1, it is a one gene code, BARX1. At the left side, you can see the numbers. And on the right side, you can see the another numbers. These numbers indicates whether, here at the top level, class in one color, control is in one color, AD, HD is in different colors. So these patterns or these colors we can notice in this genes data set. So then severity of the particular disorder from these genes data set, we can notice it. And based on these patterns, we can define our numerical value. Based on our statistical methods, we can give we can define the final standard value. Based on that value, we can process the new genes. That's the one Alzheimer's disease, that's AD. Predicting progression. ML models analyze MRI and cognitive data to predict which patients with mild cognitive impairment will convert to Alzheimer's dementia. Multimodal analysis. Algorithms integrate data from PET scans, blood transcriptometrics, and clinical tests to achieve a high diagnostic accuracy. As I already said, this is a value 0.80, which we can define it. We have to, this is our challenge, because based on this value 0.80, greater than of those values which we can process at the diagnostic stage, so we can define the accuracy of the particular disease. Non-invasive markers, analysis of gait and speech patterns to detect early cognitive decline. There may be changes in the speech patterns, not only Alzheimer's, because Alzheimer's nowadays we can notice at the age of 35, 40 also, but in earlier those days, this disorder was noticed after 60 years due to our different factors which that is influencing these mental disorders. Here the models, KNN model, nearest neighbor, SVM model, random forest, naive Bayes. These are the different classical algorithms, and whatever the accuracy we can obtain, that's the standard value I have listed here, and the precision recall F1 square FF1. These are all statistical the output or the processed data set we have listed. I have listed here. Key application in PD, variable neurotechnology. ML analyzes data from smartwatches, gait sensors to monitor tremors, bradykinesia, and gait disturbances in real time. There are many tools or the devices we have. Using these devices, so we can acquire the real-time data. Objective staging. Instead of subjective clinical scales, ML provides an objective data-driven staging of disease severity. That is our objective staging. Voice analysis. Algorithm detects subtle vocal changes that are early signs of Parkinson's. This is one of the mental disorder diseases. That is, the algorithm can also detect that one. Visual suggestion. A person wearing a smartwatch with a graph showing tremor frequency analyzed by an AI. That is also, as I said, this smartwatch is a one device which we can wear at our wrist. So it can continuously monitor our changes in our day-to-day life. The scenario, in a busy ER, minutes matter for stroke or hemorrhage. patients. These are the, I'm not, because there are, as I said, there are many, n number of mental disorders which we can, their doctors are diagnosing and noticing the symptoms and the patterns of symptoms. But we know we are not going in depth of all those mental disorders. We are looking into the at this stage for the schizophrenia and autism spectrum disorders. Rapid CT analysis. Deep learning algorithm can analyze the head CT scans for critical events. That is also one stage to analyze the data. Intelligent triage. The system flags urgent cases for immediate overview, ensuring that the critical patients are treated without delay, even if the algorithm is slightly less accurate than the human. It happens. But due to the huge data set and the different parameters, sometimes we can feel that these algorithms, it may be a second opinion, algorithm can give the better information than the clinical opinion. The data explosion. Diagnosis is not just about the images, it involves genomics, proteomics, and transcriptomics. There are many more the parameters which we can define and acquire the data, because the data sets are merged. Once we merge the data set and fetching the right pattern and the right feature, it is a very challenging. But due to our advanced classifiers and other techniques, we can process that high dimensional data within a minute to arrive at the right decision. There are tools like Lasso is there and Random Forest. That's called the biomarker discovery. Multi-omics integration, combining genetic data with image, as I already said, we are not only processing and depend on the genetic data. We can also acquire the imaging data and also clinical data. Clinical data in the sense, once the patient approaches the doctor has some questionnaires. So he has the standard questionnaires. He start asking those standard questionnaires, and based on the standard questionnaires, he make the conclusion. That's information also required to process we can input the ML algorithm, so the algorithm can arrive at the right decision. These are the different color patterns. At the left side, maybe I think those different disorders can be read. It is not readable, but I will share these slides. These are I listed the different mental disorders. Okay, that is top enriched diseases at the pink, blue, and the yellow. If the yellow is blue shows the severity of the disorders. It is at the middle range, orange color, and the yellow color shows that the person is in normal stage. Most the used algorithms: support vector machine, random forest, CNN, and artificial neural networks.
Sir, there is some technical issue from your side. You are not audible.
Am I audible, ma'am?
Yes, sir. Now you are audible.
My screen is visible.
Yes, yes.
My screen is visible.
Yes, sir.
My slides are visible. Okay, thank you.
Yes, yes.
Okay. In this slide, I have shown the different our classifier algorithms. It may be random forest and k nearest neighbor, and and also the graph shows the how the data set pattern before processing and after processing of the different classifiers. Overcoming the data scarcity problems, the challenge, rare neurological disorders lack the large data set needed to train the traditional ML, our machine learning models, because whatever the published data which we can fetch from the website, those websites are authenticated websites. Apart from these data set, we need the other parameters also, and also, as I said, genome database. Sometimes the database that is mixed with the European genes, American genes, and also the Africans. But sometimes these mental disorders and the symptoms differ from our Indian gene data set. At the time, mixing such vast amount of the different dimensional data set and making the conclusion, it's a bit difficult. Therefore, getting the real-time data set from the clinical, it is a challenging task. And these are some of the innovative solutions: brain language models, data transfer, learning. The roadblocks to clinical adoption. Key challenges: data quality and heterogeneity. ML models are the only as good as the data they are trained on. Inconsistent data from different hospitals can limit the generalizability. As I said, if it is our genome data set from American, African, and the other part of the different continent, at the time, you cannot generalize it of all the symptoms. That is the key challenge. The black box problem. Many models are not interpretable. There are some challenges. The models cannot be interpretable. They may go with the individual interpretation. Explainable AI is crucial for doctor to trust the diagnosis. As I said, definitely act as a second opinion for the doctor. Algorithmic bias. Models trained on non-diverse population may fail on underrepresented groups. I already explained about the different diversity of the genome data set. Rare disease blind spot. Most research focuses on common diseases, that is Alzheimer's diseases and Parkinson, leaving rare condition underexplored. Visual suggestion: a road with several large hurdles or warning signs. The future. Synergetic partnership, not replacement but support. The goal is not to replace neurologists. Our goal is not to replace, we cannot never replace the doctor here. Our algorithms never replace. The goal is not to replace neurologists but to create an augmented intelligence partnership. Means we can collaborate the doctor, so we can provide the information. Maybe it is 80%, 90% accurate or below that. So based on the doctor experience, I'm sure doctor will arrive at the right decision. The machine handles a rapid range, quantifies subtle changes, integrate vast data sets, and provides a great rough draft. Human provides a clinical context, empathy, final judgment, and ethical oversight. It is from Dr. Spard. Conclusion. I make the conclusion here. Enhanced accuracy. ML enables earlier and more accurate differential diagnosis of complex neurodegenerative diseases like Alzheimer, epilepsy, and many more. I have not listed all of those diseases. Unprecedented speed in acute settings. AI can triage critical cases. Data integration. Machine learning uniquely integrates the imaging, genetic, and sensor data to provide a 360-degree view of patient health. Cautious optimism. While challenges like data bias and interpretability remain, the future of neurology lies in a powerful synergy between the human expertise and machine intelligence. That's my final quote is, AI won't replace the neurologist, but neurologists who use AI will replace those who don't. This is my final slide. If any questions from your side, sorry.
Thank you so much, sir, for sharing your valuable insights and expertise with us. We shall now open the floor for a brief question and answer session. I would request the participants to raise their hands or post their questions in the chat box. Participants can ask questions.
Good morning, sir. I have one question.
Please go ahead, ma'am.
Can deep learning models outperform traditional method in Alzheimer detection?
Yes, of course. You are rightly pointed out that CNN algorithms outperforming compared to the other ML models. But some of the data set, I cannot tell which data set, some of the data sets like KNN is outperforming than the CNN model also. It depends on the data set.
Thank you, sir.
Any other questions? So one question is from Anurag Bharti. He wants to ask, what do you think about integrating BCI brain-computer interface scan be used for detecting symptoms?
BCI.
Yes, brain-computer interface scan.
That is a brain-computer interface is imaging, which we can acquire the image pattern of the particular brain scan. Based on that pattern, the radiologist, as I already mentioned in one of my slides, radiologist can give their remark. Based on the remark and the doctor experience, and with the our ML algorithm, I hope the 90% doctor can make the right decision.
Thank you so much, sir. Any question? Any other question? Okay. So,
Good afternoon. Good
Yes,
morning,
ma'am. Please
sir.
go ahead. Go ahead, ma'am. You are audible.
I would like to ask question. What are the biggest challenges in applying ML to neurological disorder diagnosis?
Could you please repeat, madam?
What are the biggest challenges in applying machine learning to neurological disorder diagnosis?
Yes, one minute. I'm sorry. These are the key challenges. In this slide, you can see the key challenges: data quality and heterogeneity. This is the main. I'm not going to other points here. This is the main challenge. ML models are only as good as the data they are trained on. If the data from different hospital can limit the generalizability, because the genome data set is not published from our Indian genome data set. It may be from America, Africa, or Asian countries. Their gene data set is entirely different from Indian. Comparing the symptoms what we have diagnosed at our hospital with those symptoms, it is difficult to arrive. Suppose the particular kid is suffering from schizophrenia and the autism spectrum disorder. There are many, more than 30 symptoms are overlapping here. There is a challenge for the doctor to arrive at the right stage which kind of disorder it is.
Thank you, sir.
Sir, Anurag Bharti saying something. So it can be used and can prove to support the use of ML as it can help in collection of data. The model can learn on. In case of autism, it can collect neural signal or image as you specified, and that can be used in making the model learn.
Yes, of course. Because as I said, in autism spectrum disorder, what happens? The doctor has a standard set of questionnaires. The doctor will go with those standard set of questionnaires, asking and marking. So in the range, there are the maybe kid maybe suffer from moderate, at the mild, moderate, and advanced. In the autism spectrum disorder cases, at this stage, doctor sometimes misdiagnose that whether the kid is in advanced stage or moderate stage, and at the mild stage. At the time, based on these stages, they can further diagnose it and prescribe some other medically therapies and other medicines. Before prescribing the medicines and the therapies, doctor has to arrive at the right decision. Definitely, the ML algorithms will be decision support system for the doctors.
Thank you so much, sir. Any other questions? Okay. Okay, thank you so much, honorable speaker and participants. I now humbly invite our respected chairperson, Professor Dr. Ravikant Jugele sir, to deliver his remarks.
Good morning and good noon, everyone.
Good morning, sir.
From bits to qubits, quantum computing and beyond. It's a one-day national conference. Our invited speaker, Dr. Ishwar Bedari sir, Professor, PG Department of Studies in Computer Science, Karnataka, University, Karnataka. Sir has explained this topic very nicely. Role of machine learning in neurological disorder. Sir highlighted very important points, how neurological disorders, conditions affects the functioning of the nervous system, which include the brain, spinal cord, extensive network of peripheral nerves. Sir also focuses on how disorder disturb the way the body communicates, process information, and respond to stimuli. Sir has also light on how the patient experience the range of symptoms such as memory loss, confusion, mood and disturbances, chronic pain, and difficulties in coordination and movements.
Sir also explained how the impact of neurological disorder is extend to families, healthcare systems, and society as a whole. Diseases such as Alzheimer's, sir has very extensively focuses on Alzheimer's, Parkinson's, epilepsy are increasingly common, especially among the aging populations. With millions of people affected worldwide and numbers expected to rise significantly in the coming decade. Sir has pointed that urgent need for more effective diagnostic and treatment approaches are needed. Sir has explained it how AI, ML, deep learning helps in diagnosing. Sir also has elaborated some algorithms. So I am very thankful to Ishwar Medari sir. He has very nicely explained the things. It's very critical topic. Interesting also, no doubt. Thank you very much, sir. Thank you, sir. Also thanks to S.C. Gulhane sir, Joshi sir, Revatkar sir, and staff of Computer Science Department. Thank you very much. Thank you, sir. Revatkar sir, especially thank you to you. Joshi sir, thank you.
Welcome, sir. Thank you. Thank you, sir. I would like to thank Dr. Praveen Joshi, sir. Because of him, I'm part of this conference today. And also, I thank all the organizing committee members. They took a lot of pain to organize such a huge task, and seamlessly they are organized. On behalf of our university and our department, I thank once again to all the organizing committee members.
Thank you so much, sir, for sharing your thoughts. Thank you very much for your valuable words. As we come to the end of this significant, insightful session on decoding the brain, the role of machine learning in neurological disorders, I take this opportunity to express my sincere gratitude to all those who made this session meaningful and successful. First and foremost, I would like to express our heartfelt thanks to our esteemed resource person, Professor Dr. Ishwar Bedari sir, for sharing his valuable knowledge and expertise with us. His enlightening talks on the application of machine learning in understanding neurological disorders has greatly enhanced our knowledge and inspired us to explore the fascinating intersection of technology and healthcare. I would also like to express our deep gratitude to our respected chairperson, Professor Dr. Ravikant Jugele sir, Associate Professor and Head of the Department of Computer Science at Sri Shivaji Science College, Nagpur, for graciously chairing this session and for his constant encouragement and academic guidance. I also extend my sincere thanks to the organizing team, faculty members, and all the participants who actively contributed to making this session interactive and successful. Once again, I thank our honorable resource person, respected chairperson, and everyone present here for being a part of this enriching session. Now, I, Ms. Harshita Nagpure, formally conclude plenary session 1 and invite Ms. Jyoti ma'am to kindly take over the proceeding for plenary session 2. Thank you. Thank you so much all. Dr. Kishore sir will join us soon. For that, we need to wait till 5 minutes. Please bear with us. Sorry, there is some confusion. We need to wait for Sable sir for 5 minutes. Kishore sir is here.
Sir, am I audible?
Yes, sir, perfectly.
Thank you.
Good afternoon, sir. Here, Dr. S. B. Kishore.
Yes, sir. Good afternoon, Dr. Sabre from VIT.
Welcome, sir. Welcome.
तर करा ना. कुठे कोणीच तर बोलत नाहीये.
Sakshi madam, you are unmute. Sakshi madam, kindly unmute yourself.
So just give us 2 minutes. There are some technical issues. Only
Okay.
2 minutes.
Okay.
Thank you so much.
Okay.
Now I am audible.
Yes.
Good afternoon to all the respected attendees, eminent resource person and chairperson, scholar and participants. I, Jyoti Yadav, Assistant Professor from the Department of Computer Science of Dr. S. Gulhane, Prerna College of Commerce, Science and Arts, feel highly privileged to be host for the plenary session 2 of this national conference on From Bits to Qubits, Quantum Computing and Beyond. This session aimed to deepen our understanding of quantum computing for everyone and introduction. Quantum computing is one of the most exciting and rapidly advancing field in modern science and technology. Unlike classical exist in multiple states simultaneously, this powerful capability open a new possibilities for the solving complex problems that are beyond the reach of traditional computing system. It's my honor to welcome our esteemed resource person for the plenary session 2. It's my privilege to introduce our esteemed resource person, Professor Dr. Nilesh Sable, sir. Dr. Sable is currently serving as a professor and head of Department of Computer Science and Engineering, Artificial Intelligence at Vishwakarma Institute of Information Technology. He is also a postdoctoral research fellow, a senior member of Institute of Electrical and Electronic Engineers, reflecting his strong academic and professional standing. He holds a PhD in a computer science and engineering from Kalinga University and an MTech in information technology with more than 15 years of teaching and research experience. He has served in a various reputed engineering institutions and has held key leadership role as a head of department. His areas of expertise include artificial intelligence, machine learning, data analysis, and data mining. He has made a significant contribution through the research, publication, book, and patent. A recent book titled Revolutionizing Medicine with Autonomous Robotics highlight the impactful role of AI and robotic in the modern healthcare. He is also a life member of professional bodies such as the Computer Society of India and Indian Society for Technical Education. With his vast academic experience and dedication to research and innovation, he is academic to inspire students and researchers in the field of artificial intelligence. Additionally, I feel privileged to welcome our honorable chairperson of session, Professor Dr. S. B. Kishore, sir. He is an eminent academician, researcher, and author, currently serving as the Associate Professor and Head of the Department of Computer Science at Sardar Patel Mahavidyalaya, Chandrapur, Maharashtra. With over 25 years of teaching experience and 18 years of research supervision, he has made a remarkable contribution to the field of computer science and higher education. He holds a 2 PhD degree in computer science and management, and he is the president of Association of all the Computer Science Teachers. He also served as a editor-in-chief of International Journal of Advanced and Applicable in Convergent Studies and Transdisciplinary. He has been actively involved in academic leadership, serving as a chairman of RT and Application Board and a member of academic counseling at Gulhane University, Gadchiroli. A prolific writer and researcher, he has authored more than 85 books and published numerous research papers in reputed journals, including international publication. He holds 7 patents and 4 copyrights and had guided 60 PhD scholars and several MPhil researchers. He contributed to education, have been recognized with several prestigious awards, including Ideal Teacher Award, the India Book of Record recognized Distinguished Award, HOD Award, and the Master Award from IIT Bombay. We are deeply grateful to have him preside over this session. Now, I would like to request and invite Professor Dr. Nilesh Sabri sir to enlighten the audience on quantum computing for everyone. An introduction. Over to you, sir.
Yes. Good afternoon, one and all. So, myself, Dr. Sabri from VIT Pune, currently heading CSEI department from last 6 years. I would like to first thank management of ESC Gulhane, Prerna College of Science, Commerce, Science and Arts, Nagpur for inviting me for this session. I would like to thank Director Dr. Praveen Joshi sir for giving me the opportunity to serve as an eminent speaker for this one-day conference on quantum computing. I would also like to thank Head of Department and Conference Coordinator of this one-day conference as a successful event for the college itself. So with this short note, I would like to start with the session. So let me know if the screen is visible so that we can go ahead with.
Yes, sir, it is visible.
Okay, fine. Facing the internet issue. Will it be fine if I can switch off the camera so that I can have the broader bandwidth?
Yes, sir.
Okay, fine. Thank you. Okay. Is it visible now?
Yes, sir.
Okay, fine. Let me make a presentation start. So yeah, that's it. So am I quite louder? We will start with this note that today we are going to deep dive into the basics of quantum, and then we will go to the advances of what applications we are about to deal with the quantum computing. So we'll start with the fundamentals of quantum, that from which idea the quantum was emerged, and it was not the new technique which was what we can say recent one which has came up. So previously we were having some Boolean algebras which were used for, that is bits we were using, and now we are using qubits for this quantum computing. There is major difference between what is probabilistic and what is deterministic. So probabilistic approach is nothing but the approach which is followed by this quantum computing, we can say. Whereas we were having a fixed approach like whether 0 or 1, where we were confident about what the outcome of the process might be. But in case of your qubits, we are not giving an outcome immediately. We are directly giving an probability that this much % of probability of getting an accuracy is there. So we'll see deep dive into that. So I will go ahead. So overview of presentation today, we are going to see this 9 aspects of quantum computing, where quantum world we'll see first what is quantum world. In quantum world, we will introduce that quantum physics differs, how the quantum physics differs from the classical understanding. Then we will explain that at microscopic level, that is nothing but atoms and electrons, and the reality behaves into probabilistic and not deterministic. So that is nothing but we are going to deal with the quantum computing that it deals with probabilistic instead of deterministic thing. The key idea behind this is nothing but the things can exist in multiple states simultaneously, that we'll see in the first part. Then the second part is why classical physics isn't enough, why we have gone forward for quantum mechanics. That is nothing but classical physics works well for large scale objects, but it falls difficult for it to deal with the atomic or subatomic levels. So for that purpose, we'll see this why classical physics isn't enough. Then we are having the next part, that is from bits to qubits, which is what the introductory part, which we'll see that how bits differ from the qubits. So in that case, qubits is nothing but the data can be at multiple states at a time. That is nothing but quantum computer use qubits, which can be 0, 1 or simultaneously both at the same instance of time, which is called as superposition. So the fourth part which we will have, that is nothing but inside a qubit is nothing but superposition and entanglement. That is nothing but simple. Superposition is nothing but multiple state at once, and entanglement is nothing but what there is correlation between one object and the another object. If we change one of the object, the another object suddenly get changes no matter how far it is, which is not there in the what we can say classical physics, which we can say it is that there is a matter of difference or matter of distance which it takes place in case of your classical physics. Here, no matter how far the objects are, the entanglement, that is nothing but your attachment is there, so that if we change one of the object instantly, the another object is affected. Then we will see why quantum computers are so powerful. This is because of some of the what we can say operations which we have like superposition or entanglement. Then we will have why quantum this quantum meets AI. We will see that now in the era of AI, how machine learning is integrated into quantum. Then in case of next, as the machine learning, you know, everywhere now it is the world of AI. So each and every industry, it is affected by AI. So quantum and AI combinedly will come up in the next decade, which is there. So we are having quantum machine learning, where quantum machine learning is used to learn the patterns, and quantum computing is used for high computing. With high computing power, it can compute maximum amount of data at the same instance of time. So handling complex data pattern can be done by using quantum computing. So the next part, we are having the seventh part, which we'll see that where quantum can help, that is real world applications, where something like healthcare or finance, that we'll see how it helps out. And the state of quantum technology today versus tomorrow, that today we are having limited scope and how it is going to advance to the next level and what will be the future of quantum computing. With this short note of overview, I will like to start the session. I hope I am quite clear and audible to each and everyone. Yes, sir. Any one of you?
Yes, sir.
Yeah.
Yes, sir.
Thank you.
You are quite audible.
Yeah, fine. So the next part, we'll start with the first part of this. That is nothing but the quantum world, a new way to see the reality. Now, in case of this, there is actually this quantum will come up in next decade, and we will be having a drastic change of AI into quantum. So now everyone is dealing with AI, but in coming decade, we will have everyone will be dealing with what is exactly the quantum and how we are going to deal with that. So first slide explains what is quantum mechanics. Basically, this slide explains the basic idea of quantum mechanics. I have break the concept into what exactly the 6 positions are. Accordingly, we'll go ahead. So what is exactly the quantum mechanics? Quantum mechanics is a part of physics that studies very tiny things. Like, for example, you can say atoms or electrons or photons. Okay. But at very small level, where what we can say the normal physics does not work properly. Okay. So quantum mechanics is advanced version of normal physics, you can say, where the classical physics does not work properly. For the small atoms like atoms or electrons or photons, we use quantum mechanics. Now, in that case, what is quantization? First, we will see. Quantization is nothing but energy comes in discrete packets called quanta. Where simple idea we'll share here. Energy is not continuous, okay? Not smooth like water flow, we can say. So it is not continuous. It comes in small fixed units like as quanta. Fixed unit is nothing but what? It is a chunk of packets which are there. As we send the data, we know what are packets. It is chunk of packets. In that case, it is the small fixed amount of unit which is called of quanta. Continuous is nothing but a waveform can be called as continuous one. So here quantization is done where the energy comes in discrete patterns called as quanta. Where we can say the next part is what? Next part is wave particle duality. Now what is wave particle duality? Particles behave as both waves and particles. Now what is this? I will tell you. Whenever we are using this, the simple idea is what? A particle is nothing but suppose a ball. A ball is called as particle. A wave is nothing but a water wave can be or a sine wave can be called as wave. Now light, if you will see light, it acts as what? Particle or it acts as wave. What it is? Light can act like a particle and also as like an wave. If we see it in both the ways, it can act as both. But electrons, whenever we are using this quantum world, this dual nature of what we can say behavior of that particle is called as wave particle duality, where wave is nothing but it has a continuous value and where particle is nothing but it has a fixed value. So remember, whenever we are dealing with any sort of problem in case of quantum mechanics, it has two different things. The one thing is nothing but what? If you'll see as a probability, it behaves as a wave. For example, suppose you are having a coin. If we toss the coin, it is whenever it is in rotating phase, it is called as what? It is a wave. So we can't judge whether it is what? Heads or tails. But whenever when it lands on the ground, we can tell whether it is a heads or tails. So whenever it is spinning, it is nothing but it is in the form of wave. And when we go for simulation or getting the final result, it forms in the form of practical. That we'll see later on. But this is what the waves and particles are there, where the particle behaves in both the states as a wave state and particle state. Now what is superposition? Superposition is nothing but a particle can be in multiple states at the same instance of time until we measure it. Until we measure it is nothing but what? For example, suppose you are having 2 bits. Okay. So for 2 bits, we know what are combinations 0, 0, 0, 1, 1, 0 and 1, 1. So superposition is nothing but unless and until we go to the measurement, this position tells that we are having 4 possible combinations which are probability. So it is called as probabilistic. So probability is what? 0, 0, 0, 1, 1, 0 and 1, 1. So when we measure it, we will come to know exactly whether it is 0, 0 or 0, 1, 1, 0 or 1, 1. So it is called as superposition. A particle can be multiple states at the same instance of time until we measure it. Now, what is difference between this superposition and the traditional one? If you see the traditional one, at the same instance of time, you will either have 0, 0, you will either have 0, 1, you will either have 1, 0 or 1, 1. Means you will have 4 different positions which will be allocated for these 4 different terms. That is 0, 0, 0, 1, 1, 0 and 1, 1. But in case of superposition, it holds 2 raised to n terms. 2 raised to n is nothing but if you have in 2 bits, it will hold 2 raised to 2 bits at the same instance of time at the same state. So whenever we are, what we can say, assisting any sort of state, so at the particular state, a particle may be measured at the multiple states. So it can be at 0, 0, 0, 1, 1, 0, 1, 1. When we measure it, we will get the exact location of that particular particle. So it is called as superposition. So as I told you in the last example, that if it is both heads and tails until it lands, so it is called as what? It is called as waves, or it is called as multiple states. Whenever we are spinning a coin, it is either heads or either tails. So we can't tell whether it is going to be head or tail. But when it lands, we go to the exact point that is called as measured. So system exists in multiple states until it is measured. Once it is measured, you will get the exact value where it is present. Now the next part is uncertainty principle. Uncertainty is nothing but what? There are 2 things, delta x and delta p, where it is given. Where delta x is nothing but it gives you the position. X gives you the position, p gives you the momentum. I repeat, x gives you the position, p gives you the momentum. So this is something like Heisenberg rule, which is there. Uncertainty principle was the Heisenberg rule which was there. So you cannot know everything exactly at the same instance of time. What is the simple idea behind this? You cannot know exactly at the simple instance of time or exactly the same time. So meaning is what? If you know the position X very accurately, for example, X आपल्याला माहित है, that is nothing but position X. If we know very accurately, then the momentum becomes uncertain. And vice versa. If we know the momentum very well, then position becomes uncertain. So uncertainty principle is nothing but 1 of delta will be uncertain for you whenever we are calculating it. So trying to, for example, trying to measure an electron. The act of measuring disturbs it. So, hello?
Yes, sir.
I'm audible, na?
Yes, sir.
Okay, fine. So this is what uncertainty is. Uncertainty may be in delta X or delta P, where delta X stands for your position, delta P stands for your, this, what we can say, momentum. Okay. So H dash is nothing but, it is nothing but H dash by 2. This is the position and momentum trade-off uncertainty principle, which was what we can say, which was designed or which was invented by Heisenberg. Now next it is entanglement. Entanglement is nothing but what I will tell you. Two particles are having correlation with them. When we alter or when we try to modify any of the one particle, the another particle is affected by sure, that is called as entanglement. Okay, so two particles become connected no matter how far or far or apart they are. Okay, if we try to modify any one of that, the another one gets affected. Okay, that is called as entanglement, which is nothing but the attachment between one particle and the another particle. Now the next part is nothing but, which is what is quantum mechanics. It comes into probabilistic outcome. So probabilistic outcome is nothing but we are having probability that whether it is going to be heads or tails. For example, coin, same example. For example, coin, if it is going to be head or tail, that is called as probability. But when we measure it, we get exactly whether it is head or tail. So remember, this psi function, psi square function is nothing but it gives you 100% probability that whether it is going to be heads or tails. So gives probability of each measurement result. So if you see quantum mechanics, it is full of these 6 functions: quantization, wave particle duality, superposition, uncertainty principle, entanglement, and probabilistic outcome. Now we'll go to the next slide where we will see what is wave particle duality and the double slit experiment. Now just you can go through this video. Now can anyone tell me what you have visualized from this? Yes, any one of you? So this slides explain the double slit experiment which provides wave particle duality. Okay. So what is wave particle duality? Wave particle is nothing but tiny things like electrons and lights behaves like particles, that is nothing but small dots or waves. So again I will play the same one. So you will come to know that if we have something like electrons and light wave, just a minute, and light, it behaves as waves or particles. So whenever you are seeing it in initial phase, you see it in the case of waves. And when you are seeing it, whenever we are transmitting it from one of the measurement one, it behaves as an particle. Okay, it behaves as an particle. So I will just explain it one by one. So first thing is what? The fire electrons, if you'll see here, we send the single electrons towards a wall. Okay, so if you'll see here in the video, we send the single electrons towards a wall with 2 small slits. Okay, so behind the slit there is a screen to detect what we can say, detect where the electron lands. If you'll see in this, what we can say, we are having a screen, so it detects where the electrons exactly lands. So what we expect, classical thinking काय आपलं, each electron would go through one slit only. Okay, each electron would go to one slit only. That is nothing but we are having a classical thinking. What actually happens? That is nothing but what? Each electron behaves like a wave. So it goes through both slits at the same time. Both slits is nothing but what? If you'll see, we are having number of slits here. So it goes through multiple slits at the same instance of time. So waves from both sides interface with each other. Okay. Result of this is what? We are having a bright lines and we are having dark lines. So waves, if you'll see here, just a second. Okay. So if you'll see here, we are having a bright lines and in between we are having dark lines. So what is bright lines? Waves are added up, and what are dark lines? Waves are cancelled out. So remember, it proves wave behavior. Now we observe the electrons. Now what are the electrons? The result is what? We place a detector to check. Now the detector is nothing but this in between result is nothing but a detector. It goes through only one split. Detector what defines that? It goes through only one split. So after measurement, what happens? See now, after measurement, if you'll see here, you will see that the waves are converted to what? The waves are converted to particles. So in between this particle, now we are having what? We are having a bright lines and dark lines. So now as a particle, if you'll say, the dual, what is this wave particle duality is nothing but there are two ways of seeing the electron moves. The one way is what? We see it in the form of waves. The another way is nothing but once we measure it, it appears to be as a particle. So first thing is fire single electrons one at a time at two slit. Then each electron passes through both the slits simultaneously. An interface pattern builds up on a detector screen. So as in the figure, if you'll see now, we are having an interface pattern which is detected on the screen. If we observe with the split interface pattern, it disappears. Okay. So this is what your dual particle reality is there. The key concept of this function is nothing but we are having the wave function which is there. So wave function is nothing but it is called as psi function. So wave function represents all the possible paths, whereas your particles gives you the exact line. So whenever the what we can say the conclusion of this slide is what? If we are doing no observation, it appears as an wave. No observation means we don't have any sort of detecting device or detector screen, something like that. It will behave as an wave. But if we have something like detector device, like your detector screen or something like your interface pattern detector, then it will appear as an particle, which will give you what? Which will give you two lines. One is your dark line and one is your bright line. So that is duality behavior as an wave and as an particle. So this is all about the slide. Now next slide we'll go for the Schrödinger equation. Now Schrödinger equation for wave function. Now what is Schrödinger equation for wave function? Just give me 1 minute.
Okay, sir.
Now see what is Schrödinger equation and wave function. The slide introduced one of the most important equation in quantum mechanics. Now in quantum mechanics we are having this Schrödinger equation and which is for your wave function. Okay, and explain how it describes the behavior of tiny particles. Okay, so here in the equation we are having I of h bar equal to delta psi upon delta t. Now what is delta psi? Delta psi is nothing but it is the wave function. This is the most important concept. It represents the state of the particle. What is delta psi? It represents the state of the particle. It contains all the information about the system. That is nothing but your delta psi, which is nothing but your wave function. Now what is simple meaning of this? It tells where the particle might be. Okay, delta psi tells you where the particle might be. And what is delta if we have only psi function? Remember psi square, adi sangidlo hoto mi. Psi square is nothing but it gives you the probability. So if we square the wave function, now psi, as I have told, it is the wave function. If we square the wave function, we get the probability density. That is what we are having this. So psi square, if the probability density is high, particle will be there. That is nothing but particle is likely to be there. And if psi square, that is nothing but your probability is low, particle unlike to be there. So remember, depending on your psi function, we can give the probability that whether the particle exists or not exists. So if your psi square value is high, the particle will exist. If your psi square value is low, the particle is unlikely to be there. Okay. Then we are having Hamilton operator. So H here, capital H represents Hamilton operator. Now it represents total energy of the system. What is Hamilton operation? It represents operator. It represents the total energy of the system. It includes total energy is nothing but it includes all the energy. That is nothing but kinetic energy, potential energy, whatever are there. It includes all the energy. It tells how energy affects the particle behavior. It tells how energy affects the particle behavior. Remember I of H bar. What is I? I is nothing but the imaginary number. And the value of imaginary number always in maths is nothing but root of -1. Root of -1. So that is nothing but I we are having. Then we are having H bar. H bar is nothing but it is reduced Planck constant. So value of that it is given here. That is nothing but 1.055 into 10 raised to -34, which is given here. That is nothing but the value of your H bar, which is nothing but used for this. So delta psi upon delta t, it is nothing but change over time. It gives you particle change over time. So how the wave function changes with time is given by delta psi upon delta t, and then we get the total equation. So understanding the wave function is important. So high peak, high probability, low points, low probability. Depending on probability, we can say that whether the particle exists or not exists. Remember, very simple classical physics, electron moves in a fixed path. Whereas in case of your quantum physics, electron exists as a probability cloud. So whenever we are dealing with quantum physics, classical physics, we know that this electron moves with a fixed path, then what will the speed of that electron, and everything is fixed whenever we are dealing with your classical physics. But whenever we are dealing with this quantum physics, electron exists as a probability cloud. Now, whenever we are having this probability cloud, then what this equation does, that is Schrödinger equation, what it does, it predicts this cloud and find where the electrons is likely to be on that cloud. So for that purpose, this equation is used. So is it clear to everyone? Am I audible? Okay. So this is fundamentals which we are having before quantum computing. So now why classical physics is not enough, that we'll see, and then we'll move forward with qubits and what we can say, what is bits and what is qubits. Now whenever we are dealing with this classical physics, remember I have one comparative table if you'll see here. So classical physics developed by scientists like Newton, describes the motion of large objects like car, planets, everything is what? Having some measurable format in case of classical physics. We are having two figures which are given here. The blue one shows you the classical physics. The second one, that is, it shows you the quantum physics. Quantum physics gives you what? It gives you the probabilistic values. Whereas your classical physics gives you the fixed values. Remember, where classical physics मध्ये काय काय होतं? Classical physics describe the motion of large objects like any of these. What, for example, Newton, apple falls. So it is having one of the objects like apple. Then we are having planets. Then we are having cars. Now what is quantum physics? Quantum physics deals with your tiny objects like atoms, electrons, photons. So these tiny objects are classified or dealt by the quantum physics only. So we'll see first the scale. Classical works with a large scale, whereas large scale objects, whereas quantum physics works with an atomic and subatomic scale objects. Okay, so motion of cricket ball, we can find it by using classical physics. Motion of electron, we can find it by using quantum physics. Now what is state of particle? As I have already told, state of particles are always fixed and the momentum is also fixed whenever we are dealing with your classical physics. But whenever we are dealing with quantum physics, only probabilistic values are known. Probabilities are known. We don't know the exact speed. We don't know the exact position whenever we are dealing with your quantum one. So for example, for an electron, you can only say that it is likely to be here. Okay, it is likely to be here. But in case of your first case, that is classical physics, you can throw a ball and you can calculate exact speed and where it is going to be land. That is called as your classical physics. Then we are having measurement. Measurement does not affect system whenever we are dealing with classical physics. I repeat, as we know everything like position, momentum, everything, measurement केल्यानंतर त्याच्यात काही फरक पडत नाही. That is called as your classical physics. Measurement doesn't affect anything whenever we are dealing with your classical physics. But whenever we are dealing with your quantum physics, remember, measurement changes the system. How it changes the system? Suppose quantum physics deals with what? The spinning coin. And when we measure it, it has to be heads or tails. So it changes its position from wave to the particle. I repeat, it changes its position from wave to the particle. Wave is nothing but what? Spinning coin. And what is particle? Whether it is heads or tails. Defining that exactly is called as particle. So measurement changes your wave into particle. So it is called a dual functionality. That is what we have explained earlier. So the next part is nothing but your energy. Now what is energy? In case of classical physics, energy is continuous. Whereas in case of quantum, it comes in pieces. As already I have told you, it comes in pieces. Pieces is nothing but it is discrete packet like 0 and 1 or 1 or 0. There can not be any intermediate value between 0 and 1. So that is what it comes into discrete packets. Okay. That is what your energy is there. Then locality. What is locality? Locality is nothing but local introduction. Objects affects only nearby objects. That is nothing but what? As we are having this classical physics, if there is small distance between one or two objects, then only they can affect each other. If we change one, then the another one changes. If there is far distance from each other, this what we can say, or global interaction is there, classical physics doesn't work. In that case, we use quantum physics. Quantum physics is non-local. Whatever the distance may be from one particle to another particle, if we try to, what we can say, change one of the particle, if we try to have any sort of what we can say alteration into one of the particle, the another particle gets affected. That is called as entanglement. So that already we have discussed. Then what is determinism? Determinism is nothing but in classical physics, future is predictable. Predictable is nothing but what? I will tell you. Suppose we are driving a car and we are going from with a speed of 100 kilometers and we have to go 60 kilometer. So we can determine that at what time we will reach there. That is called as classical physics. But in case of quantum one, it is probabilistic. Probabilistic is nothing but it will give you that the probability that you will reach at this instance of time, 70% probability, 80% probability, 90% of probability. So in this case, it is probabilistic. It is not deterministic where the values are not fixed. So it is probability. So this is what the difference between your classical and quantum physics is. So remember, classical atom, whenever we are dealing with this probability and all this is, there is vast difference between classical physics and quantum physics. Now we'll go to the next point, that is uncertainty principle. Uncertainty principle was developed by Heisenberg, which is delta x into delta p greater than equal to h bar by 2. So delta x, as already I have told you, it is nothing but it is the position uncertainty which is there. Position uncertainty is nothing but what? Can anyone tell what is position uncertainty? And uncertainty in momentum. Delta p is nothing but uncertainty in momentum. So, and the next one, that is h bar, is nothing but your reduced Planck constant which is there. So remember, what is uncertainty in this? Remember, if you try to measure position very accurately, momentum becomes very uncertain, and vice versa. If we try to measure momentum very accurately, position becomes uncertain. Both cannot be precise at the same instance of time. Okay. So in that case, remember delta x, delta p. Okay. So these are the values which affects by one another. So it is called as, we are having that if we try to calculate delta x, delta p will be affected. In classical physics, what happens in classical one, exact position, exact speed, everything is predictable. But in case of quantum physics, does not have exact values simultaneously, only probabilities exist. Okay, reality itself is uncertain. In the same way, quantum behaves in the uncertain way. Okay, so for example, I will tell you how we can explain this. For example, your classical ball. Okay. If energy is less than the, for example, here, if you'll see the figure which is given, if energy is less than the wall height, ball cannot cross the wall. Okay. So if you want to throw the ball from one end of the wall to the another part of the, what we can say, land, then we have to throw it from above the wall. So remember that if the energy is less than the wall height, ball cannot cross the wall. That is called as behavior is predictable. Now, what is quantum? Even if energy is less, okay, there is a small chance it passes through the wall. And this is called as quantum tunneling. This is called as quantum tunneling. So if you'll see the second image which is given, that in first case, we come to know that if we throw it, it will ripple back and it will be landed in the same ground. But in quantum case, we have a small probability. What is probability? That is, it passes through the wall. That is called as quantum tunneling. So why uncertainty lands to struggle effect? So because of uncertainty, remember particles don't have fixed paths. Okay, they behave like wave. So now here the ball is considered as an wave, so they behave like wave. They cannot tunnel through the barriers, exist in multiple states. So remember, it is always uncertainty principle which is there. So this Heisenberg uncertainty principle was introduced, which was position uncertainty and momentum uncertainty was given. One line conclusion for this, if you will say, in quantum physics, the more precisely you know where a particle is, the less precisely you will know how it is moving, and vice versa. So the output of this is nothing but one is always uncertain in case of delta X or delta P. That is what it is. Now we'll go to the next part. These are the hard problems for classical computers which are not solvable or it takes maximum time. So we have gone forward for the quantum computers now, where we are having maximum, what we can say, computational power to solve any critical problem within a fraction of seconds by using quantum computing. So these are some classical problems, classical computer problems which they are unable to go off. And then we come to the next now, from bits to qubits, quantum approach. So now first we'll see what is classical bit. Now classical bit, everyone knows, as everyone knows with the digital system and all that thing, a bit is a fundamental unit of classical information. It is always either a 0 or 1. So classical computing starts with bit. A digital information is stored is bit like 0 or 1. Means at the same instance of time, it can be 0 or 1. For example, a button of your light, switch of your light can be either on or off. So in the same case, it is either 0 or 1. So binary iterations are there, 0 or 1, 1 or 0. A bit is always a smallest unit of information which is used. So we are having bit, byte, double, quad and all that things. You know everything about that. So classical computers use millions of bits to process a data. Now, whenever we are using millions of bits to process a data, remember, at certain extent of time, we are having complications regarding that. And to avoid these complications, we have qubits. So why bits are not enough? The reason for that bit checks solutions one by one. So they become too slow for huge problems. If you are having huge problems, you will have n number of bits and it will be the process of solving that particular problem will be too slow. So bit force everything into either this or that. Means whenever we are dealing with bit, it will be either 0 or 1. So it forces either to choose this or either to choose that. While many real situations are not so simple, for example, there may be an intermediate level between this and that. So that is not considered in case of your bits. As a problem grows bigger, bits quickly become overwhelmed and impractical to use. But if the problem is too bigger, the quantity of bits is too large. So it is impractical to use that particular bits. And so we have gone forward for the next one. That is nothing but your qubits. Now, what is qubits? Am I audible? Because I've not heard it.
Yes, sir.
Okay, fine. Thank you. So now the quantum bit is nothing but it is called as qubit. Qubit is a basic unit of quantum computing. Unlike a classical bit, a qubit can be 0, 1 or both. at the same instant of time. That is nothing but it behaves as wave. I repeat, whenever we are seeing a qubit, we are not measuring it. It behaves as 0, 1 or both at the same instant of time. Suppose, for example, आपण 2 bits जर घेतले, तर it can be have 2^2, that is 2^2 bits. So it will have 4 possible combinations. So it will behave as 0, 0, 0, 1, 1, 0, 1, 1 at the same instance of time because we are not measuring it. But when we measure it, it will give you whether it is 0, 0, 0, 1, 1, 0 or 1, 1 exact value it will give. It's called as particle. Remember what is wave, what is particle. Whenever we are not measuring it, it is called as wave. Whenever we are measuring it, it is called as particle because it has to give one specific output in case of that. So now if you'll see so here again I will repeat, a qubit is a classical bit but much more powerful, can be only 0 or 1 classical असतं ते, आणि qubit असेल तर it can be both, that is called as superposition. It can be both is nothing but both 0 and 1 at the same instant of time, त्यालाच आपण काय म्हणतो, we say it as a superposition one. Okay, that is it holds the multiple states simultaneously. That is qubit can exist in multiple states simultaneously, so it is called as superposition. Okay, now mathematical representation, if you will see, it is psi is greater than equal to alpha 0 plus beta 0, beta 1. Now what is psi? Psi is again, it gives you the state of a qubit. Already we have discussed this. It contains all the information about your qubits. Now what is alpha 0 and beta 1? These are the basic states like classical 0 and classical 1. These are numbers if you can say alpha and beta. So probability alpha 0 is nothing but what? Probability of getting 0 and probability of getting 1. So alpha square is nothing but what? Where alpha, if you will see alpha square plus beta square, alpha square is nothing but it gives you probability of getting 0 and beta square gives you the probability of getting 1. This is nothing but what? The total probability is always 100%. That is nothing but whether you will get a 0 or whether you will get a 1. Important rule is nothing but what? Alpha square per beta square is equal to 1. That is nothing but your total probability of getting 0 or 1 is nothing but it is 100%. So what happens when we measure the things? When we measure the things before measurement, qubits is in superposition form. That is, it is in 0 or 1 form or both at the same instant of time. After measurement, it becomes either 0 or 1. So this is the collapse of quantum state. Okay. So why qubits are powerful here? Classical system मध्ये काय होतं? Classical system only one bit, one value at the same instant of time. Whereas in case of your qubits, one qubit is equal to multiple possibilities at once. For example, n qubits असतील तर किती possibilities झाल्या? We will have 2 raised to n states simultaneously. We will have 2 raised to n states simultaneously. What is the use of this? We will have faster computing. We will have parallel processing. So these two are the major advantages of qubits, that we are having faster computational power and we are having parallel processing. So remember, whenever we are dealing with a simple system, one bit is having only one value at the same instance of time. But in case of this quantum system, n qubits are having 2 raised to n state at the same instance of time. So that is what it is. Next we'll go fast. I think so we are short of time. So yes, inside a qubit and superposition, if you'll see, we are having what we can say superposition and entanglement. I have already discussed this. Just for reference, once again you can go through this. Superposition is nothing but it can be at 0 state, 1 state, or simultaneously at 0 and 1 state. That is called as superposition. So classical bit is nothing but a still coin, whereas a quantum in superposition is nothing but a spinning coin. Superposition allows quantum computer to explore many possibilities at the same instance of time. That is called as your superposition. Remember this. Now next we are having entanglement, powerful because quantum parallelism. Quantum parallelism is nothing but what? What is quantum parallelism? At the same instance of time, you can work what? Parallelly. So in classical computer, one input, one output at the time. In quantum computer, a qubit can be in many states simultaneously. So the system can evaluate many possibilities in one step. Okay. Now to evaluate function for what we can say for input like 0, 1, 2 and 3. Your classical computer will take 4 times separately, whereas all this input can be encoded at once whenever we are dealing with this quantum computer. Okay, so if you'll see, parallelism is the one of the feature of this. So we can have with n qubits, it works with 2 raised to n inputs in one step. So that is what parallelism is there. Then we are having quantum algorithms. If you'll see, the quantum algorithms are developed from 1994, and now we are having many algorithms which are there, which are for this. So Shor's algorithm, we are having this. What it does, it finds the factors of large number of what we can say large numbers very quickly, like your RSA encryption, if you can say. Then we are having Grover's algorithm. Grover's algorithm, what it does, it searches unsorted database. Okay, if you are having an unsorted database, you can search in that unsorted database by using this Grover's algorithm, used to search unsorted data faster than the classical methods it is given. Then we are having HHL algorithm. HHL algorithm, it solves systems of linear equations. So if you are having any sort of linear equation, that can be solved efficiently by using this HHL algorithm. Then we are having modern hybrid algorithms like VQE and QAOE. VQE is nothing but variational quantum agent solver, whereas your QAOA, that is quantum approximate optimization algorithm. So for what purpose these are used? They are used to solve optimization problem and find lowest energy state in your chemistry. So for that purpose, these algorithms are used. So these are some key quantum algorithms which are used in market now. So quantum meets AI. So this is one of the most important part which you will see now. Quantum meets AI falls into the category of what? It is combination of quantum and machine learning. So quantum computing plus machine learning is nothing but what the current era is all about. Machine learning teaches computers to learn the data. That is what machine learning is. So we are having multiple data which are available, and it teaches the computer to learn the data and get the insight from data. What quantum computing that? It uses qubits and quantum effects to make the system more powerful. So QML tries to make learning faster and more powerful. Now these two are combined together. Learning faster is done by using your ML, and more powerful is done by using your this quantum one. So remember, it is combination of both machine learning and quantum computing. So encoding of input data, then we are having quantum processing, and then we are having output and learning. Now encoding of input data is nothing but converted into quantum state. That is nothing but we are converting the data into qubits. Okay. Then quantum processing, quantum algorithms run on that particular data. It uses superposition, it uses entanglement, it uses quantum parallelism, and then we get an output and learning. That is nothing but measure the quantum system, and the results will be, you will get some sort of trained models, or it will make some predictions which are there. Okay. So this is all about your machine learning. If you will see any sort of machine learning term, it has 4 outputs like classification, pattern recognition, data analysis, optimization. Now see, whenever we are dealing with this, if we detect something, for example, you have detected as an diabetes, so we cannot cure it completely. We can optimize the effect of that. So if it is detection, it is always optimization. And if it is prediction, so if we predict that you are about to get an diabetes, then we can have some sort of recommendation system. So if it is prediction, we can go for recommendation system. That is what your quantum machine learning QML is there. Now there are types of QML models. If we'll go through it, you are having number of types of QML models which are given here. Okay. So quantum supervised learning model, where we are using labeled data. We are using for classification and regression. We are having quantum unsupervised learning, where we use unlabeled data, finding the patterns, cluster structure. We are having quantum reinforcement learning, where learns by trial and reward, where we are having decision making problem. Then we are having variational quantum models. What is variational quantum models? Trained like neural networks. It works like neural network, uses parallelism, quantum circuits for that. Then we are having quantum neural networks. So QNN, where it is quantum version of neural network, combines quantum circuits plus the learning. So it is combination of quantum and the learning which we are having. Then combines classical machine learning, that is nothing but the hybrid model, which is called as quantum classical model, where it combines classical machine learning, that is quantum processing, and most practical approach today. That is what we are using, that is hybrid classical, quantum classical models. Then we are having variation quantum circuits. Variation quantum circuits are like VQC, that is variation quantum circuit. It uses a quantum circuit, then they are controlled by parameters like weights, and the parameters are optimized using what classical computers. That is what the variational quantum circuits are. So we'll not go into depth for this. Remember, in this VAC, how it works, I will just tell you. First, we encode the data, then we apply the quantum circuit to that, and then we measure the output. Once we measure the output, we optimize the parameter as per the requirement of user. So this all process is called as VEC, that is variational quantum circuits. Okay, what we can say, why this VQC is important? Because complex computations can be solved in case of this whenever we are dealing with this. Okay, so current quantum computers or quantum computing computers are limited, so we are using this VQC. Okay, where we can go for VQC is used for classification, pattern recognition, you can say optimization problem. So for all this purpose, VQC is used. Now next we are having real world applications. So now I have divided this real world application, like for drug discovery, quantum chemistry, we can use quantum computing. What is complexity? What is quantum solution? What is quantum versus classical? All the insights are given here, which is nothing but we can use quantum computing for drug discovery. We can use quantum computing for finance and optimization. Like complexity, like financial models involve huge data and many variables that can be resolved by using quantum computing. Classical methods struggle with the risk analysis, portfolio combination. Optimization is important. So all this can be done by using this quantum computing. So quantum solutions are provided here, where we are having portfolio optimization, which gives you the better asset allocation and solves the complex optimization problem also. So this is when we are using it for finance and optimization. We can use for cryptography and security also. So quantum key distribution, we can use it for cryptography and security. We can use BB84, that is nothing but it detects any sort of unwanted disturbance or any sort of interference into a data which we are having. So that we can use for cryptography and security. Last point, today versus tomorrow. We are having the state of quantum technology now. So remember, whenever we are dealing with this, classical computers are nothing but what it uses approximation. It has slow and less accuracy. Whereas whenever we are dealing with this quantum system, it uses a quantum algorithms. They are good for small molecules like S2. It is basically used for small molecules like protons, and already we have done. And the models are model molecules here with your qubits. Okay, so that is what we are having into this intermediate scale quantum. Now these are quantum hardware platforms. We'll not go into depth for this. We are having some superconducting platform by IBM, Google, and many more, which are providing now quantum computing platforms. Then we are having quantum error check. Yes, this is one of the important part, where the error checks are done by QVC codes, that is quantum error check codes, and then it detects it and fix it by its own. So preserve the quantum information by using this quantum error check. Next, the future of quantum. Yes, in 2024, 2025, we are having this NISQ park. Now, these are the predictable future of quantum computational complexity and quantum advantage. So we'll have near about 1 million plus qubits in 3235. So the quantum advanced version will come in 3235. It will be full error corrected universal quantum computer, that is AI accelerated. So full AI integrated quantum will be coming up, predictable. It is in 2032 to 35. So this will be the change in era whenever we'll be in 30s of this, what we can say, decade. Okay. So open challenge and research frontiers for each and everyone, we are here. So qubit scalability is the open challenge. Classical simulation barriers are an open challenge. Error correction overhead is one of the open challenge. Data encoding bottleneck is open challenge. And then we are having something like noise in near term. That is also open challenge. So there are open challenges and research frontiers where we can work on this quantum. Okay. The future is quantum. Classical is not enough. Quantum is not optional. So each and every one of us has to deal with this quantum one or the other day. Quantum mechanics governs the reality at the smallest scale. Quantum will be the future of the coming era. So post-quantum cryptography must be adopted now. So 2030 is going to be the peak era for that. So depending on that, we are having various advantages of this, like QML combines quantum advantage with machine learning and so on. So this is all about the quantum from my side. I will just stop sharing the screen. So thank you for your patience listening, because as we everyone know that whenever we are dealing with quantum, it is quite what we can say technology shift from one state to another state, where we are dealing with multiple aspects of quantum. Traditional computing comes to 0 and 1, whereas the quantum computing comes to multiple state at the same instance of time. And whenever it measures, it changes from a wave form to a particle form, where we get one exact output of that particular thing. So thank you for patience listening. Over to you, ma'am.
Thank you, sir. Thank you so much, sir, for your enriching and thought-provoking session. Your valuable insights have significantly deepened our understanding of the theme. Yeah, and open a new avenue for learning. The depth of knowledge, your knowledge combined with a clarity of your presentation was truly inspiring and left a lasting impact on all of us. We shall now open the floor for a brief question and answer session. I request the participants to raise their hand and post their question in the chat box.
Okay, I will open the chat box so that I can address it. How can
so there is
algorithm
a-
selection? Yes, I will just take it. How can algorithm selection impact the accuracy of quantum ML model? Algorithm selection doesn't affect the accuracy of quantum ML model. What affects is nothing but there are two states. The first state is what? Measurement state and non-measurement state. Whenever we are dealing with quantum, we are dealing with non-measurement state. Unless and until we come to certain algorithm to calculate it, that is measurement state. Whenever it comes to measurement state, it will give you the exact output of that particular state. For example, as already stored, we are having 2 raised to n combination for each and every point. So whenever we are dealing with 2 raised to n, unless and until we go for any sort of algorithm for measuring it, it reflects that we are having 2 raised to n states. But if we go to any sort of algorithm, it will give you that which exactly state it is having. That is what it is there. What is quantum parallelism? Quantum parallelism is the same. That is nothing but what? Instead of working at the same time on 0 and 1, we are working with 2 raised to n combinations at the same time. So that is what quantum parallelism is there. By saying quantum physics is probabilistic, do you mean that measurement or results are dynamic for an electron? Yes, it is. That is what it is. The change in duality that we have already discussed. Change in duality is nothing but what? Probabilistic is nothing but what? Unless we measure it, it forms an wave. It affects as an, we can see the photons in the form of waves. But we measure it, it will reflect as an particle. So you will come to know that where exactly it is going to land. So probabilistic is nothing but by default quantum output is not sure that it will be 0 or 1. If you are calculating anything by using quantum physics, remember it will never give you that the output will be so. It will give you 70% probability of getting this output. It is always probabilistic whenever we are dealing with this quantum physics.
There is one question from Anamika Bhagat, ma'am.
Anamika Bhagat. What fields will benefit most from quantum computing in future? Okay. In case of fields, ma'am, we are having a traditional shift from what we can say classical traditional environment to now AI. So each and everything what we are processing now, it is processed through AI, or each and every sector which we are having, interdisciplinary sectors are affected by AI. But going forward, it will be a combination of AI to solve these complex problems of data. So the major sector will be benefited wherever the data is there. We will be having a quantum computing in the future, because AI, everything, whatever AI is there, it is all about data. And if it comes to a huge amount of data, we can't have classical computers to analyze that particular data. We should have a quantum mechanism. We should have strong computational facilities which can analyze that particular data. So each and everything which deals with data will be affected by this quantum computing.
Sir, there is one more question from Sneha Ambikar ma'am.
Let me see. What impact will quantum computing have on cybersecurity? It will be like proposed as in one slide I have shown. In 3032, 35, if we go through the quantum computing, it will be foolproof solution for cybersecurity, which is proposed through this quantum computing. We can't have what we can say now. Our answer is also probabilistic, that it is whether it is going to be there or not to be there. But as stated, if everything goes fine with the quantum era, then we will have a foolproof system for cybersecurity solutions through quantum computing.
Any other questions? Okay, thank you. Thank you so much, sir. Honorable speaker and participants. Now I would like to request and invite Honorable Chairperson, Dr. S.B. Kishore, sir, for his remarks. Over to you, sir.
Thank you, madam. Thank you. First of all, let me congratulate the Nilesh sir for this excellent presentation that he has given. So I sincerely thank him for delivering a very clear and engaging section on the quantum computing for everyone introduction. Through his presentation, he has explained the complex ideas in a very simple and easy to understand manner, so that shows the clarity and the depth of the knowledge that he has. Okay, his session has helped every one of us to understand the basics, right from the classical to quantum, and has also created the interest to learn more about the important and growing field of called as quantum. From my perspective, being a computer science professional, which Sabli sir also conveyed during his presentation, that quantum computing represents the next major shift computing, where we move beyond the classical limitation to solve a problem that are currently very difficult to solve or very time consuming, like when you are talking about the optimization problem or improving the cryptography or accelerating the drug discovery or handling the large scale of data more effectively. So these are some of the problems which we are facing right now. But of course, through the quantum, definitely we are going to solve all these major problems in a near future. So in short, it has a strong potential to influence the areas like algorithm, data processing, and security in the coming years. Now, if someone asks me what are the key takeaways from this particular session, I can say that he has explained the basic concept in a very simple manner. Now we can understand, or we can understood how quantum computing is different from the traditional and classical computing. We got an idea of its real-world application via AI and quantum. The session encouraged to explore the real research work that one can carry out. So we can say that we have a long way to go from Stone Age to the age of computing, and now we are stepping in the era of computing. And still, it is just the beginning, and we have a long journey to go ahead. So finally, once again, I would like to thank Sabri sir for expressing the concept in a very simple manner. I also thank to organizing committee member, especially Principal Dr. Nabin Madam, Director Praveen Joshi sir, Coordinator Dr. Revatkar sir, and all other organizing committee for organizing this particular conference on such a relevant theme and inviting me as a chair session. So once again, thanks to one and all. Over to you, madam.
Thank you, sir. Thank you so much, sir. Your remark has surely added richness of the session and help us reflect more deeply, sir. With this enriching perspective in mind, I have now proceeded to conduct session 2 with a formal vote of thanks. On the behalf of the Dr. S.C. Gulhane, Prerna College of Commerce, Science and Arts, I express my heartfelt thank or esteemed resource person from Professor Dr. Nilesh Sable sir for an intellectual enriching plenary lecture. Your session has surely inspired us to expand our horizon with regards to the depiction of quantum computing. I extend my sincere gratitude to our respected chairperson, Dr. S.B. Kishore sir, for graciously presiding over this session and guiding it with academic depth and clarity. I would also like to thank organizing committee and technical team for their constant support in making this session is a session of success. I would also like to thank all the participants for their attentive presence and active engagement. Thank you all once again. Now, I, Ms. Jyoti Yadav, formally conclude a plenary session 2. And dear participants, we would like to inform you that we will now take a lunch break until 2 p.m. We will reassemble at 2 p.m. for a plenary session 3. Kindly remain available. Thank you.
Thank you.
Thank you, Kishore sir.
Thank you.
Thank you so much, sir.
Thank you. Thank you all.
Thank you, sir.
Thank you.
Millet, sir.
Yes, sir. Thank you.
Okay, sir. Thank you.
Thank you. Thank you so much. Hello.
हर्षिता शुरू करना है। हर्षिता।
Sir, we have to wait for 5 minutes.
हो गया क्या समय?
We will start the program, sir, at 2 o'clock. Sir, guests are joining in 5 minutes. Then we will start. Some settings are going on for PPT presentation, so bear with us. Good afternoon to all respected dignitaries, eminent resource person, chairperson, scholars, and participants. I am Ansi Denge, Assistant Professor from the Department of Computer Science at Dr. S. Gulhane, Prerna College of Commerce, Science and Arts. We are highly privileged to be the host for the plenary session 3 of this national conference. This session aims to deepen our understanding quantum computing, small qubits, big possibilities. Quantum computing is one of the most exciting, rapidly developing area in modern science and technology. Unlike classical computers that use bits, quantum computing uses qubits, which have the unique ability to exist in multiple states at the same time. This remarkable property opens the door to solve the complex problems and are extremely difficult for traditional computers. It is my honor to welcome our esteemed resource person for the plenary session 3, Professor Dr. Robins Porwal sir. Serving as a professor and head of the Department of Computer Application at Chhatrapati Shahuji Maharaj University, Kanpur, Uttar Pradesh. He has with more than 23 years of experience in academic and research. He has made significant contribution to teaching, research, and academic administration. He has previously served in several reputed institutions including Lal Bahadur Shastri Institute of Management, New Delhi, and Institute of Technology and Science, Ghaziabad, where he actively contributed to teaching and research. He completed his PhD in software engineering from the Yabag Education Institute and also hold an MTech in computer science from Jamia Hamdard. His research interests including software engineering, big data analytics, artificial intelligence, data science, machine learning, and data analytics, which are among the most important areas shaping modern computing. He is an active professional member of prestigious international organizations such as Institute of Electrical and Electronics Engineering and the Association of Computing Machinery, along with several national professional bodies with the vast academic experience, research contribution, and the dedication of advancement of computer science. He continues to inspire students, scholars, and researchers in this field. We are truly honored to have such a distinguished academician among students. In addition, I feel privileged to welcome the Honorable Chairperson of the session, Dr. Ashish Sasankar sir. He is a visionary academic leader currently serving as a principal, and he is also officiating chairman of the Indian Council of Technical Research and Development. He is a recognized NAAC assessor, actively contributing to quality assurance and institutional excellence in higher education. With over 25 years of rich experience of teaching in research and academic administration, he has established himself as a leader expert in this field of artificial intelligence, data science, cloud computing, and machine learning. His work focuses on bridging the gap between a technical excellence and institutional growth. He has been honored with several prestigious recognitions, including the Best Principal Award in 2025 from the Rashtrasanta Tukadoji Maharaj from University Nagpur, and has been listed among the top 100 educators worldwide by International Biographical in India. His research contribution include more than 70 papers, and he also successfully guided 90 PhD scholars. He also holds over 70 international certificates from the renowned organizations such as Microsoft, IIE, and ESIR, showcasing his global academic engagement and continuous pursuit of knowledge. He continues to inspire educators, research, and students alike. We are deeply grateful to have him preside over this session. Now, I would like to request and invite Professor Dr. Robis Porval sir to enlighten the audience on quantum computing, small qubit with possibilities. Over to you, sir.
Porval sir, namaskar. Sasankar sir, namaskar. Thank you, both of you, for accepting our invitation and joining us today for this conference. I'm sure that with your presence, this conference will turn into a wonderful one.
Sure, sir. Sure.
रबिन सर, आपकी आवाज नहीं आ रही है.
Rabin sir, I think mic is off. Not audible, sir. Please check your mic.
Sir, maybe your mic is off. So please check your system volume.
System volume must have been lowered, I suppose.
Yes, maybe so.
पुरवाल सर, आपको हमारी आवाज आ रही है? आपकी आवाज हमें नहीं आ रही है.
Sir, voice is not audible. I think that you can reconnect.
Am I audible now?
Yeah.
Now you are audible. Right.
Yeah.
Fine. Thank you so much. Thanks, Dr. Praveen sir, for inviting me, Dr. Leeladhar. Good afternoon. Am I audible?
Yes, sir, you are audible. You are audible.
Okay, okay. Because I have connected this headphone. Maybe there is.
Okay.
Okay, and my screen is visible.
Yes, sir, your screen is visible.
Yes, sir.
Okay, 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 okay. Okay, I'll try my best to fulfill the objective of the workshop, the conference, which actually being organized at the college. And I'm really thankful to Dr. Praveen sir, Dr. Leeladharji, for giving me the opportunity to share my thoughts on quantum computing. And so let me start. So today in the morning, I have seen, I was just looking at the program schedule. So several talks have been conducted onto the quantum computing, right? So, and many of the things, basic things would have been covered definitely. So again, there may be some repeated things, obviously. So, but I'll be discussing very basic concepts of the quantum computing and what is bits, what is qubits, and what are the applications and how the quantum computing is emerging nowadays, and it has become a buzzword. And now every person is after AI actually, and not only after AI, we can say in parallel with artificial intelligence, quantum computing is evolving. And what are the problems which were not solved before, so the solutions of those problems can be provided with the help of the quantum computing because of its performance, high performance, though it is challenging in today's scenario to devise a quantum computer. Still, there are some corporates in India and in abroad. They are working in making the devices related to the quantum computer based on the concept of the quantum computing. So the title for the talk is I have taken small qubits and big possibilities. So bit is, again, we know it is 0 and 1, but qubit is somehow a little bit of before the you can say lesser than bit. And with the inclusion of the probability, now there are a lot of chances of considering so many things. So I'm just moving ahead. Is my screen visible? Okay. So what is quantum computing? So quantum computer, obviously it's a machine designed to use the principles of quantum mechanics to do the things which are fundamentally impossible for any computer built on only based on the classical physics or the classical bits which we have studied like 0 and 1. So explaining what is qubit and how it can be used like this. So is my screen visible and it is being shown in running?
Yes, sir. Yes, sir. Go
Right.
ahead.
Okay. The quantum model,
sir,
the qubits. Right. Thank you. So on a normal computer, we store information in the form using bits, and we all know bit is 0 and 1. So a bit can be either in the state of 0 or in 1. And physically, we can store a bit in some object that has two states, like coins of the like you can say 0 and 1, right? And a qubit is nothing but a quantum bit. So it is stored. Hello, am I audible?
हाँ बोलिए ना, आप कहाँ पहुंचे?
Right, am I audible?
कहाँ खड़े हैं आप?
Sir, yes, sir. You can go ahead for that.
Okay.
I request Praveen sir, please switch off your mic, sir.
Okay, no issue.
Yeah.
So a qubit is stored in a tiny physical system like an individual atom that behaves quantum mechanically. Right. Let me just go ahead with this. Right. So here we can see 0 and 1. So as well as being in states corresponding to 0 or 1, a qubit can be anywhere in between 0 and 1. So qubit can be anywhere in between 0 and 1. So here alpha and beta are any numbers. In fact, more generally we can say that they are the complex numbers which satisfy the equation like alpha square plus beta square is equal to 1. Though this may be a little bit technical, so I'll try to minimize the technical part and moving ahead so that it could be understood by everybody. So this is what is called the superposition. So if we have n qubits, they can be in superposition of 2 to the power n different states. So obviously, if there are n qubits, then they can be in the superposition of 2 to the power n, right? 2 to the power n different states. And this allows a quantum computer to run an algorithm on many possible inputs simultaneously, right? So we have a very small video to describe what the qubit is, right? I'm just going to run that video and let me share this video on the screen. Entire screen. I have taken the entire screen, and is this visible? Is this video is visible?
Yes, sir. Yes, sir. Go ahead.
Okay, I'm just going to play and let me and kindly confirm whether it is audible or not, right?
Yeah.
Sir, it is
playing-
audible.
Okay. Is video audible? I'm just asking because I
No.
have played the video.
No, sir. Video is not audio.
Video is not audible, but your
Okay.
screen is visible. Yes.
Okay, screen is visible, and let me check why it is not actually. It should be audible because I have given the permission. Okay, if the video is not audible, then there is no problem. It is a self-explanatory video, so you can understand just looking at the how it is being played actually, right? Is video being displayed?
Yes, sir.
Okay. A qubit can be considered a bit as cat 0 and cat 1, right? So here it is shown. It is the combination of alpha and beta. This is called the quantum superposition, alpha and beta. So qubit can be anything between 0 and 1 or the combinations of both, right? So bit can be either 0 or 1, right? So it is being shown here. We need to learn about alpha and beta. So qubit is state unit vector or a complex in a complex vector space. So it is qubit can be anything between cat 0 and cat 1. Concept of qubit is actually taken, or quantum computer is taken from quantum mechanics or quantum physics actually. how the power of quantum mechanics can be utilized to describe the qubit and the quantum computing. So here the concept of the quantum mechanics is actually taken, which is actually taken from the quantum physics. Right. If this audio is not visible, is not audible for this video, I'll be sharing the link. This video is already available on YouTube. I can share the link with the organizers. So, sir can share this link with all the participants, so they can listen this video later on. Right. So, continuing with the presentation, let me just. So there are two terms, measurement and entanglement. So if we measure some qubits, we see some outcome with probability equal to its corresponding coefficient, which is squared, like alpha square and beta square, as we were talking about previously. So for example, imagine we have two qubits in the state, and here 0, 0 and 1, 1 with these alpha and beta square values. So then if we measure the qubits, we get outcome to be 0, 0 or with the probability 1 by 2, and the outcome 1, 1 with the probability 1 by 2. So but what if the first qubit is in somewhere else and the second is on some other position, some other state, right? So it seems that the measurement result in at one place has instantaneously affected the qubit on the other place. So here this is the example taken from between Bristol and Moon, and the Bayesian phenomenon is known as the quantum entanglement, and this is what is known as the quantum entanglement, right? There are two popular algorithms which are used in quantum computing. One is called the source algorithm and other is called the Grover's algorithm. And these are actually used for, the source algorithm is used for factorization, and factorization has a lot of applications in computer networks, basically in RSL algorithm. So it is, so any talk is incomplete if we do not going to discuss about what is source algorithm, what is the Grover's algorithm, and where these have applications. Source algorithm is proposed in 1994. We will look at its historical timeline of this quantum computing, starting from 80s until till the present situation where we are today. So integer factorization, everybody knows, given an integer like n, and we can divide it into, we can factorize it into two prime factors like p and q for prime factors p and q, and we need to find the value of p and q. Obviously, if we take n to be 15, the output would be 3 and 5, and 3 and 5 both are prime numbers. Right, now we are going to generalize. Source algorithm, which is actually proposed by Peter Source in 1994. He described a quantum algorithm which can factorize large integers efficiently. And no efficient classical algorithm is known for this problem till now. So this has applications in quantum computing, quantum computers. So what is factorization in cryptography and where this factorization is actually used? So we should, why should we care about integer factorization? This is the reason. Why? Because the RSA crypto system, RSA algorithm is used in cryptography, which actually underlies internet security, relies on the hardness of the integer factorization. So if we could factorize large numbers efficiently, we could break this crypto system. So if we could factorize large numbers efficiently, then of course we can break this crypto system. And in 2009, a 232-digit number was factorized using hundreds of computers over a period of 2 years. So it took 2 years to factorize the numbers, which is 232-digit number. By comparison, a large quantum computer could factorize the number with thousands of digits in a matter of minutes. So here, where you can see the quantum computers play a very important role, which a classical computer, classical techniques cannot be used. cannot be used to solve such types of problems. And this is what is the Grover's algorithm. So one of the most basic problems in computer science is unstructured search. Artificial intelligence in AI, we study like structured searching techniques, unstructured techniques, semi-structured like this. Okay, so this is the most basic problem in computer science, unstructured search. So Grover's algorithm is actually useful here. So imagine we have n boxes and each containing a 0 or a 1. And we can look inside a box at a cost of 1 carry. So we want to find a box containing 1. So we need to, what's the problem? We need to find a box which must contain 1. So on a classical computer, this task could require n queries in the worst case, because if there are n boxes, the n queries in worst case. Now, but on a quantum computers, by the Grover's algorithm can solve the problem with roughly square root of n queries. So again, this is again a very important application, or you can say the application of one quantum algorithm, which is actually proposed by the Grover, known as the Grover's algorithm, to provide the solution, better solution in comparison to the classical solution or solution provided by the classical computers. Now, there are a number of different technologies which could be used to implement a quantum computer. There are a number of different technologies. I have a video, again, there will be a problem on the audio side, right? So I'll tell you what are the implementation. Before that, how the quantum computers basically work, right? So quantum computers are devices that use the principles of quantum mechanics to perform complex calculations. As we have seen, the problems or the calculations which cannot be performed by any classical machines or the classical systems. So unlike classical computers that use bits, quantum computers use quantum bits, which is known as the qubits. As we have, bits can exist in multiple states simultaneously, allowing for parallel processing and faster computation. In classical computers, we use bits either 0 or 1, but in qubits we use the multiple states in between 0 and 1, right? So we can perform the computation faster and in parallel as well. What are the algorithms? These are the two algorithms which I have already discussed. Like source algorithm can factor large numbers exponentially faster than classical algorithms, and which have a very good impact on cryptography. And Grover's algorithm can search unsorted database faster, improving data retrieval efficiency. So they are the two very, very most important algorithms, and these are used. Quantum machine learning algorithms can enhance pattern recognition and data analysis. So when we need to identify or we need to recognize the pattern, so this can be enhanced by quantum machine learning algorithms, which are known as the QML. And I think one of the speaker has already spoken on QML algorithms today in the morning session, as I was looking at the program schedule. And the data analysis. Right. What are quantum computer limitations? So there are a lot of advantages, lot of things which can be, or a lot of complex problems which can be solved by the help of the quantum computing or the quantum computers. But there are obviously there are some certain limitations which are shown in this diagram. So error rates, reliability of calculations. So quantum computing versus classical computing to calculates with qubits which can represent 0 and 1 at the same time. So qubits, we can use the 0 and 1 and or both at the same time. But in classical, we can be representing the calculates the transistors which can represent either 0 or 1. In the case of quantum computing, power increases exponentially in proportion to the number of qubits. But in the case of classical computing, power increases in a one-to-one relationship with the number of transistors. Quantum computers have high error rates and need to be kept ultra cold, right? But in the case of classical computers have low error rates and can operate at the room temperature. So that's why the quantum machines are placed at very ultra cold locations, right? So there is one organization, I think, which is called the Pi organization. Name of the organization Pi, which are actually working quantum computing, situated in Bangalore. This company is so they have implemented their quantum computing systems, and they are very effectively using and providing the solutions, very real life problem solutions to the real life problems. So well suited for tasks like optimization problems, data analysis, and simulations. So this is quantum computing is well suited for the tasks like optimization problems, data analysis, and simulations. And most everyday processing is best handled by classical computers, as we are using in today's scenario. So quantum computers are not suitable for all types of problems, and certain computational tasks may still be better suited for classical computers. So we need to be very careful what types of problems are to be solved with the help of the quantum computer. ऐसा नहीं होना चाहिए कि हम we will be providing solutions for all types of problems by the quantum computer. We need to look at the problem whether it can be solved by the classical computing algorithms or not. Then we should go for the quantum computing. The quantum algorithms require careful design and analysis to exploit the advantages of quantum computing. There are a number of different technologies which could be used to implement a quantum computing. So this is what is the diagram, the image, or some part of slides are taken from University of Bristol. So photonic quantum circuits on silicon. So it is taken from there. So again, the World Optis, University of Bristol, they are working a lot in the area of the quantum computing. And this is the image taken from NIST. So they are working on the machines which are actually based on the quantum computing, quantum algorithms. So now the timeline, theory of quantum computing. So as we know, every term which are buzzwords nowadays, or every new technology which are buzzword nowadays, obviously it started a long back. So in 1984, if we look at the quantum cryptographic key distribution invented by these two persons, Bennett and Brassard. So in 1984, the concept of quantum cryptographic key distributions was invented. Though in 1830s, with the advent of when the Charles Babbage proposed some algorithms related to the punch card or something like this, at that time, he also discussed about this thing. And in 1930s, Alan Turing also discussed about when he proposed the Turing test. At the time, he talked about a little bit of for the quantum world means when the quantum physics and the quantum mechanics can be utilized to provide the solutions where the classical problems cannot be used, or classical machines cannot be used to solve the problems. Right. So in 1985, general quantum computational model was proposed. In 1992, first exponential quantum speed up discovered. 1994, quantum teleportation invented. 1994, which I was talking about, the source algorithm, rewrites the rule book of the classical cryptography. Source algorithm was proposed for the factorization. The 1995, quantum error correcting codes was invented. Quantum simulation algorithm was proposed. So you can see over the years there has been some improvement in the area of the quantum computing every year. Starting from 1984, 85, 92, 93, 94, 95, 96, quantum simulation algorithm proposed. 1990, the quantum speeder for unstructured search problem. 1990, efficient quantum communication protocols. 2003, exponential speeds up by quantum works invented. Then quantum teleportation demonstrated quantum error. So you can see, but in the last, with the you can say just after the pandemic or the COVID period, quantum computing evolved heavily. And the government of India, they have started a national quantum mission, NQM. You all would have heard about it. And one of the center has been established at IIT Kanpur as well. They are working on the quantum computing, means how the concept of the quantum physics or the quantum particles or quantum mechanics can be utilized, or how a quantum machine can be, a quantum system can be built, right? So all these things have been evolved over the years, and in parallel with the artificial intelligence, machine learning, though everybody has studied the machine learning algorithm, but how the concept of the quantum can be utilized with the machine learning to propose a new idea, which is called the quantum machine learning, and how the quantum world can be the concept of quantum. When we talk about the concept of the quantum, we are talking about the qubit, and when we talk about the qubit, means we are talking about the both possible state 0 and 1. So how this concept can be utilized with already existing algorithms in the classical classical computers, so that we can provide the solutions to those problems which are very complex and which could not be solved by the concepts of the classical bits. So that's why we have taken the small qubits, means small qubits and big possibilities. Small qubits means we are talking about bit. When we talk about the bit, it is 0 and 1. We talk about the qubit, means we are talking about both states and in between both. So it has become a little bit lesser than, or you can say the smaller than the 0 and 1, and how this concept can be utilized to provide the solutions to the bigger solution, or to the bigger problems, or the bigger real life problems, right? So again, I have a video again, so there will be a little bit problem. You all may not listen the audio, and let me skip, or I'll play the video later on. So what are the key quantum computing applications where it is utilized? So this is one area: pharma industry, drug discovery, and healthcare. So quantum computers can simulate molecular structures and interactions at an atomic level, so accelerating the drug discovery and enabling personalized medicine through faster genetic sequencing. Okay, so quantum computers can simulate the molecular structures and the interactions at the atomic level. So here we can see the applications of the quantum computing in the area of the pharma industry, or you can say the drug discovery and the healthcare. And again, logistics and supply chain optimization. How can we optimize the logistics and supply chain with the help of the quantum systems, or the quantum computing systems? So these systems can solve complex routine inventory management and warehouse scheduling problems to minimize fuel consumption and improve delivery times. So again, the quantum computers can play a very important role in logistics and supply chain, in optimizing or in providing the optimized solution by reducing, by minimizing, or you can say reducing the fuel consumption and improving the delivery times. Again, financial modeling and risk analysis. So the algorithms which we study in classical systems of classical machines. So obviously they are not, though with the help of the artificial intelligence, machine learning, and deep learning, they are providing the solutions to the several solutions to several financial problems, and how these can be modeled, and how the risk can be analyzed, but not at the not providing the efficient solution. So we can look for the efficient solutions with the help of the quantum computing. So algorithms can analyze high-dimensional financial data to optimize portfolios, detect fraud, and predict market trends faster than the classical systems. So, here you can see the application of quantum system or quantum computers with the help of the qubit in providing the solution, optimize portfolios in detecting the fraud, online fraud which actually happened, and predicting the market trends faster than the classical systems. Some more application areas as well, like material science and energy. So quantum systems aid in developing better battery materials for e-vehicles and optimizing the chemical processes to improve efficiency in renewable energy sectors. So this is what is one more area where the quantum computers or the quantum systems can play a very efficient role. And as we know, in recent time, there is a problem related with the fuel, and we are facing this because of the war. So you can see, and day by day, the numbers of e-vehicles are increasing. And when we talk about the e-vehicles, we are talking about the materials which are to be utilized in the battery. Okay, so how the efficiency of the battery can be made better with the help of with the use of the better materials actually. Again, you can see, as you can see, divided numbers of e-vehicles are increasing over a period of time. What will happen after 5 years or 10 years down the line? What is going to happen to those batteries which will be discarded from the e-vehicles? It is again a problem which will arise after 5 years or 10 years. How to utilize or where to dispose that e-waste. So this is again a problem. Okay, so with the help of the quantum computers, we can reuse the material which is actually used in making the battery, right? Or we can optimize the chemical processes to improve efficiency in renewable energy sectors. Quantum machine learning, and as I just discussed, everybody is talking about the artificial intelligence, machine learning, and at the same time the word qubit evolved and the quantum computer. So how the concept of the quantum can be utilized with the machine learning, means the quantum machine learning and AI. So quantum algorithms can enhance our AI by training models faster, enabling better classification tasks and improving natural language processing. Okay, so as we all study in machine learning, there are some classical problems, the classification task and the clustering task, and NLP is one more area. There are some other algorithms which are actually reinforcement learning when we talk about the deep learning. So how the concept of the quantum or the qubits can be utilized with all these running concepts related with the artificial intelligence to make the classical algorithms better. Weather forecasting and climate modeling, and this is the problem which we are facing now in today's scenario. So everybody is actually looking or can see the forecast at their mobile applications. Means when it is a sunny day, when it is going to rain, when how much the temperature is there. Obviously, the artificial intelligence is playing a very important role with the help of the machine learning algorithms in providing all these predictions or the forecasting. But to get the most better solutions or the most better predictions, the quantum computers or the qubits can play a very important role in all these areas, whether forecasting and the climate modeling. So quantum computers can simulate complex atmospheric processes to provide more accurate and long-term climate predictions and extreme weather modeling. Cryptography and security, obviously, before the emergence of, you can say, the quantum computers, the concept of the quantum cryptography was proposed by many of the mathematicians, basically, right? So cryptography and security, while they threaten current encryption, they are also used to develop quantum safe cryptographic algorithms and secure communication protocols. When we talk about the cryptography, means how we can use the concept of the quantum computer with the cryptography to provide the quantum safe cryptographic algorithms, and how we can provide the secure communication protocols, right, with the help of the quantum computing. And now we have one more video. So before this, let me play a video. Mhm. One more video related with the quantum computing in 5 minutes, right? I'm just going to play it. This is very simple video which I have taken from I've downloaded from YouTube. I think it is also available just to understand what is the quantum computing and what are the quantum computers. Is this video audible? Sorry, is this video is visible or not?
No, sir, your video is not visible.
Okay. Let me share the entire screen now, and let me now. Okay,
Yes.
is this video visible?
Yes, sir, definitely.
Okay,
Yes.
but it is not audible. Okay, I'm just going to play. It is not audible, right? Okay, so let me. How can I make it audible? Is there any way or the procedure? Or is there any setting? Is there any setting related to playing the or to make the audio audible? I'm just going to play the video. So there are two persons, Dave and Rayan. So Dave wants to know how computer works actually. So Dave does not know. So computers give the first move. So flip the coin, either it can be 0 or 1, head or tail. Now the second turn or third turn is taken by the computers and the result is taken to be. Is this video visible?
Yes, sir, your video is visible.
Okay. So there are possibilities. It is head is taken to be considered 0 and tail is to be taken be 1, and all the possibilities between 0 and 1 are being considered within the quantum computers with the help of the qubits. So it is being shown 0 and 1, some portions of 1, and it can help you in identifying whether a game can be win or lose. The concept of the superposition and entanglement of quantum physics are taken. सिक्योरिटी में, एप्लीकेशन सिक्योरिटी, हेल्थ केयर. It can be used in creating the private keys between the two. This is just an example of encryption, how quantum computers can be. And these are the companies which are actually using the concept of this quantum computing in the security, like JP Morgan, Wells Fargo, and Barclays. Can be used in the pharma industry with the help of the atoms and molecules, work on the similar concept. So here is a question. What makes quantum computers different from supercomputers? Obviously, atoms and molecules. Right. So let me. Right. So there is one more video related with the quantum real life applications of the quantum. I'm just going to show you. Though some of the real life applications have already been discussed, I'm just going to share. Hello.
Sir, बहुत अच्छा.
Am I audible?
Yes, sir, you are audible.
Okay, one more last video, very small video, real world application. I'm sorry, the audio is not.
No, it's okay. It's okay.
Not. I can share the links. Though these videos are available online, I've taken. These are not created by me. These are already available. Okay. So, but the important thing is each and everything is explained very nicely in these videos. Okay, and let me just play this last video. Is this visible audio? Oh, sorry, video.
Yes, sir.
This
Yes,
video
sir.
is
The
visible?
video is
Okay.
visible. Yes, sir.
But audio is not there. Okay. But this is a very good video which tells about the real life applications of the quantum computing. So again, the application of quantum computing in drugs and healthcare, and application of quantum computing in AI. There are many complex tasks which can be solved by the help of the quantum computing. Let me. Let me just share.
Thank you, sir. Thank you so much. Thank you so much, sir, for your
Thanks for
enriching.
patience listening, and thanks for giving me the opportunity. Though this area is very emerging, and I would like to I would like to congratulate to the organizers of the basically Dr. Praveen Joshi, Dr. Leeladhar, and his team for organizing national conference on such a very emerging topic actually, because everybody is talking about nowadays artificial intelligence, machine learning, but you thought something different actually. Okay, and how the quantum computing can be utilized. Okay, and this is emerging actually, and you'll see in the next 6 months or 1 year, you'll see a lot of research and a lot of people, they have started working, they have started organizing the events related with the quantum computing. But you are actually the first one who actually started organizing the conference on this very emerging topic. Thank you very much. Thanks for
Thank you, sir. It was a wonderful presentation, and you have taken great efforts while preparing this wonderful presentation. We are really lucky to have you as one of the resource persons, and the insights that you have shared with us will be of immense benefit to all of us.
So thank you very much. Thanks for patience listening. I discussed the topic at a very, very low level and at the very basic concepts. I did not discuss anything very much technical things, only discussing about the qubits and what is the quantum computing and where the quantum computing can be utilized to provide the solutions to the real life problem.
At this stage, sir, it is more relevant, in fact. It is more relevant. The scholars and the researchers must be acquainted with this kind of idea initially, so that they can study it deeper and deeper levels.
Right.
Yeah.
Thank you very much, sir. Thank you.
Thank you, sir. Thank you. Yes, please continue, Anchor.
Your voice is not audible.
I invite Dr. Ashish Sasankar, sir, to make his remarks on this.
Yes, thank you, sir. Thank you very much.
Thank you, sir. Thank you.
Respected dignitaries, Dr. Praveen Joshi, sir, esteemed resource person, Dr. Rabin Porwal, my friend Leeladhar Revatkar, and dear participants. As we come to the end of this enlightening session on quantum computing, a small qubits, big possibilities, I would like to take a moment to reflect on the key takeaways. In today's discussion, has clearly highlighted the quantum computing is not longer just a theoretical concept, but the rapidly advancing a field with the immense potential to revolutionize industry and research domain area. The ideas such as small qubits can solve extraordinary complex problems truly opens new horizon for the innovations and also for the scientific progress. I sincerely appreciate the insightful and thought-provoking presentation along with the lots of videos delivered by the Dr. Ravin Porwal, sir. His expertise has helped us to understand both the fundamentals and the future scope of the quantum technologies in a very clear and engaging manner. I also tell to the students and research scholar, they have given lots of research topic such as based on material science and energy. Even you can collaborate quantum machine learning with the AI, weather forecasting and climate modeling. Here also you can do the lots of research, and we know that cryptography and security is also now based on this particular quantum computing. I also commend all the participants that their active involvement and keen interest throughout the session. Your curiosity and the engagement are what make such academic discussions meaningful and impactful. I would like to express my heartfelt gratitude to the organizer for giving me the opportunity to session this chair. Let us carry forward the knowledge gained together and continue exploring vast possibilities that the quantum computing offers. Thank you once again. Thank you all.
So much.
Thank you. Yeah.
Wonderfully summarized.
Thank you, sir. Thank you.
Anybody, if anybody has any question, you can put that question to these experts who are before us. If anybody has any question, please ask. Let it be a kind of interaction.
Because this is
Right.
very emerging technology we are using, quantum computing, and lots of research scholar has this is the means we can say that we have the lots of potential in this topic.
Right.
So we have the
Exactly.
Rabin sir is over here. So any participant are interested to ask anything, please ask. Go ahead.
Yes, I have got a question. How do researchers get big possibilities from just a few qubits? Okay, how do researchers get big possibilities? Okay, so obviously this is a very good question. And how do researchers get big possibilities? Obviously, qubit is very small, and as in the classical computers we see there is only 0 and 1, but qubits actually consider both the states simultaneously or together, 0 and 1, and along with all the possible states between 0 and 1. So obviously the possibilities are increases of the problems which are not actually solved by the classical computers or the classical systems. The quantum computers actually plays an important role. So qubits is small in the sense, but its applications are too much. A lot of research papers have been published. Okay, and obviously this is very emerging area, and we need to explore more and more what peoples have actually proposed, what research area have been proposed with the help of the qubits, and how a quantum computers can be built. Obviously, I can tell one or two organizations in Bangalore which are actually, they have developed their own quantum computing systems, and they are providing solutions to a lot of real life problems with the help of the quantum their machines or the systems. So qubit is nothing but, as we talk about the bit. So obviously in classical computers we talk about the bit, and we provide the solutions, lot of solutions to a lot of problems, right? So similarly, qubit is a very small unit, and the qubit actually being a very small, obviously, but providing the solutions to a lot of those complex problems which could not be solved yet efficiently. Right, so that's why the researchers get big possibilities from just a few qubits. And one more question: what breakthroughs are needed to move from small qubit systems to large-scale quantum computers? What breakthroughs are needed to move? Okay, obviously there are a lot of things which are actually required. Qubit is a very small thing, and I covered very basic thing. But when we study more and more about the quantum computers and quantum computing, the algorithms, we need to study a lot of things like the linear algebra. We need to know the concepts of the Moore's law, physics, laws of physics, and all the. Obviously, the whole of the quantum computing system is actually based on the quantum physics, and quantum physics is obviously based on the concept of atoms and the molecules and the particles. So obviously, all these are required to be studied, and how these concepts can be implemented in the form of the machine or a computing machine. Okay, so to provide the solutions. right? So there are a lot of research papers. I have missed to include one slides for further reading actually. Though I prepared that thing, so I have identified so many links so that you can explore those links and find a lot of things related with the quantum computing. So while sharing all these slides, I'll be putting that slide there. There are a lot of links related to the researchers in the quantum computing or the organizations which are working in the quantum computing and they have developed their own quantum computing systems. So I'll be putting there and I'll be sharing with the with Sir Praveen sir and Leeladhar sir, and you can get the slides from him.
Thank you so much, sir.
Thank you.
Your thoughts are really work for us, and your insights have added immense value to our understanding of theme, and we certainly inspired further discussion and research.
1 minute, please, 1
And,
minute. I would like to ask, I would like to
Yes, sir.
have something from these two experts. Dr. Carl Sagan sent a spacecraft from NASA in 1977, on 20th August 1977. And Dr. Carl Sagan says that it took us 6 weeks to prepare that capsule with all the information of the Earth. It had 55 languages, 99 different symbols, how humans on the Earth look, what they do, their various activities, and various sounds. So that capsule was prepared by NASA, and Dr. Carl Sagan was the pioneer, the main scientist there, the main brain there. So he says that with all the computer data available with us, all the supercomputers available with us, it took us 6 weeks to prepare the spacecraft and to gather the information, put into that and send the spacecraft to the space.
Right.
Now, when I was reading about this quantum computing, qubits, so one of the scientists or one of the educationists said that it took them 6 weeks to prepare the entire data and send the spacecraft to the space. But now with the quantum leap in computing, it will
Right.
take only 6 days
6
to
days.
analyze
Right.
the data and to calculate everything. Sir, is it really possible? The 6 days, 6 weeks work
Yes, sir.
done within 6 days?
Yes, sir. It is possible. I discussed one example related with the factorization of 232 bits. The factor of 232 digit. Classical computers took more than 2 years to find the solution, but with the help of the quantum computers, it could be solved within minutes.
Oh. It is possible.
So,
it is possible.
Within minutes, not in minutes. You can say within
No,
some
they said
days.
6 days. Instead of 6 weeks, it could be
Yeah,
6 days.
Yes. It is possible because quantum. When we talk about the quantum computers, obviously we look at all the possible states, including 0 and 1, both 0 and 1, and all in between.
The
So obviously-
speed and the complexity
Right.
of the issue will
Definitely.
be solved in minutes.
Right. Bilkul. It
So,
is.
sir, could we be leading towards super quantum leap?
Definitely after along with the AI actually, and now we are moving towards super AI, right? So obviously with the help of the quantum computers will be able to achieve this objective, right? So definitely it is possible.
Thank you, sir. Thank you very much.
Sir, thank you, sir. And thanks for sharing this information with me too. Actually, it is really an information for me too. Thank you, sir. Thanks for sharing the example.
It's pleasure listening to you. Your presentation was wonderful. And the summing up done by Dr. Sasankar was
Thank
also
you.
great help to us.
I'm honored, sir. Thank you.
Same here, sir. Same here. Yes, please continue.
Yes, sir. Thank you so much, sir. Your thoughts and your remarks surely added a richness to the session and help us to reflect more deeply in this session of the topic. And with this enriching perspective in the mind, I now conclude plenary session 3 with a formal vote of thanks. On behalf of Dr. Gulhane, Prerna College of Commerce, Science and Arts, I felt my express thanks to our esteemed resource person, Professor Ravin Porwal sir, for an intellectual enriching plenary lecture. Your session has surely added and inspired us to expand our horizon with regards to the depiction of quantum computing. I extend my sincere thanks to our esteemed resource person, Ashish Sasankar sir, for graciously presiding over this session and guiding it with academic depth and clarity. I would also like to thank the organizing committee and technical team for their constant support in making this session a success. I would also like to thank all the participants for their attentive presence and active engagement. Thank you all once again. Now I am answering it. Formally conclude plenary session 3 and invite Ms. Rajeshri ma'am to kindly take over the proceeding for the paper's presentation. Thank you so much. Have a good day, sir.
Thank you. Thank you. Thank you.
Thank you, Ravin sir. Thank you. Thank you.
Thank you, sir. Thank
so
you.
much.
Thank you, sir. Thank you.
If you happen to come to Nagpur, kindly give me a call.
Definitely, sir. Definitely.
You shall be our honored guest.
One of my senior, he belongs to Nagpur, Professor S. Ketkarji. So definitely I'll be visiting. I'll be definitely.
Sure, sir. Right, sir.
Thank you very much.
Right, sir. Thank you. Thank you very much. Sasankar, sir, thank you.
Thank you so much, sir.
पेपर प्रेजेंटेशन शुरू करो. श्वेता मैडम ज्वाइन कर लिया आज.
Yes, sir. Join हो गए, madam. Yeah, Rashmi, madam.
Yes, sir. Good evening. Join.
Who is the anchor?
Sir, Rajeshri, madam.
Rajesh madam, please continue.
Good afternoon, all respected dignitaries, honorable judges, esteemed participants, and dear attendees. I, Ms. Rajshri Akre, Assistant Professor from the Department of Computer Science at Dr. S.C. Gulhane Prerna College of Commerce, Science and Arts, feel highly privileged to be the host for paper presentation of this national conference on From Bits to Qubits, Quantum Computing and Beyond. It is my privilege to welcome you all to this online paper presentation session of our conference. We are truly delighted to have such an enthusiastic gathering of scholars and researchers presenting their valuable work today. Before we begin, I would like to take a moment to acknowledge and express our sincere gratitude to our respected judge. Your expertise, experience, and insightful evaluation play a crucial role in maintaining the academic quality and integrity of this session. We are honored to have you with us and look forward to your valuable feedback and guidance. It is my pleasure to introduce Dr. Shweta Barhate, Madam, Associate Professor in the Department of Electronics and Computer Science at Rashtrasanta Tukadoji Maharaj Nagpur University, Nagpur. She completed her MSc in Computer Science from Sri Shivaji Science College, Nagpur in 2004. Followed by an MPhil in 2008, qualified the UGC NET in 2006, and earned her PhD in Computer Science in 2020. She has over 14 years of postgraduate and 7 years of undergraduate teaching experience with research focused on cloud computing and interoperability issues. She has successfully completed a minor research project funded by RTMNU on cloud interoperability and has actively participated in workshops, seminars, and delivered guest lectures at the HRD Center of RTMNU. She has published numerous research papers in reputed national and international journals, presented her work at conferences including Indian Science Congress, and has also received a copyright and a patent for her research contribution. She has also authored a book and contributed to book chapters with international publishers, reflecting her strong commitment to research and academic excellence. In addition, she has actively contributed to academia by participating in workshops, seminars, and delivering guest lectures at the HRD Center of RTMNU. Now, let us proceed with the paper presentation session. Each participant will be given maximum 5 minutes to present their paper. I kindly request all the participants to adhere to the time limit to ensure the smooth conduct of the session. Now I invite our first presenter, Ms. Prashni Naidu, to present the paper titled A Cross-Platform Job Aggregator System. Ms. Prashni Naidu, over to you.
Thank you, ma'am.
Ms. Prashni?
Yes, ma'am. Good afternoon, everyone. I am Prashni Naidu, student of MSc CS second year, Department of Computer Science, and Dr. S.C. Gulhane, Prerna College of Commerce, Science and Arts. Today, I am presenting my research paper titled A Cross-Platform Job Aggregated System. Today's generation, there are the peoples are applying for the job through the various of the online platforms. There are the various real-time job platforms are available, but they are sometimes the time consuming and also confusing. The users need to switch between the different platforms to searching their job, as there are many companies uses the software like the ATS system, that applicant tracking system. If the user resume is a less score of the ATS score, then they are being rejected, which is a serious issue for searching the job. To overcome this problem, there is a need of the system, which is the combination of the various real-time platforms, and also help to improve their ATS score of a resume, and also prepare for the interview into the single platform. As I told you, there are the many job opportunities are available, but they are in different platforms like the LinkedIn, Indeed, Naukri.com, and etc., which is sometimes hard to search the relevant jobs for the user. The candidates are logging to the different of the platforms to search their relevant jobs, and due to their poor keyword matching and the low ATS score, many resumes are also being rejected for the good job listing. There is a no proper system are being developed nowadays that the shows the job by matching the user skills and the relevant jobs. And there are no platforms that give job opportunities in a single platform, and also help to user to improve their skills, improve their interview preparation, and also improve their resume by using the ATS software. To solve this problem, these systems are being developed that merge the multiple real-time platforms into the single, also help the user to identify the
gap between their skills and the market demanding skills, and it's also helped the users to prepare for the job and also improve their communication skills. There are the many existing real-time job portals like the LinkedIn, Indeed, and etc. But they are work independently. There is a no combination of this all platform into a single platform. There are also some platform that uses the resume parsing techniques. Also, there is a some platform, there is a job aggregation. But this system is a job aggregated also helped a user to improve their skills, improve their resumes, and also help to prepare for the interview. The process of this system is the user needs to sign up and log in with their credential. After login, the user needs to simply upload their updated resume. By uploading the resume, this system is extracted the relevant information like the education, experience, and skills of the user that are all important details to find out the perfect job match. But after that, this system is fetches the job from the real job portals that are merged in this system, that are the Adzuna and Jobble and JSearch. These jobs are listed to the user according to their skills that are mentioned in their resume. The user also filter that the job listing by adding their skills and the roles that they want and the job type like the full-time, part-time, or the freelancer. By applying these filters, they can also find out the more job according to that the user. The user can simply click on the apply button. It can also apply for it and it redirect to the real job portal. Then the implementation. This system is built up by using the Python and Flask framework. This also provide a user-friendly platform that the user can simply log in, upload their resume, and the paid job are listed to them. The resume data is extracted by using the text processing techniques, and the external or real-time job portals API keys are also added to get and fetch the real job data. These also show the match score between the skills and the job description that are fetched. It is also calculated and easy to update and apply for the user. And it also take a less time than the other platforms. This is the result of this system. There is a dashboard which gives a brief introduction of the system. Here, the user can sign up in that system by logging their username and password, and after that they log in it by their credentials. After that, this is on the home page which give and show all the features of this system, that how to improve the applicant tracking system score to improve their resume. Also get the various job recommendation according to the matching data that are fetched from the resume. Also applies the filters according to the user needs. It also merges the different real-time job portals into the single portal. Also help a user to prepare for the aptitude test, HR test, technical skills. Also improve their communication skill through that career preparation portal, and also help for the freelancer to get a freelancing job in this portal. After that user login, this is a upload resume page where user simply needs to upload their resume. After that uploading the resume, this system is fetch the data from the resume by using the text processing technique. After that, after getting the important relevant information, according to that, it shows the job matching jobs, also matching score. Simply apply button, it redirect to the real portals, and it the user can also add their skills, roles, job type, and experience according to what they want. After click on the apply filter button, it shows the relevant job according to that filter. Also help to improve and also show the ATS score of the resume by adding the market demanding skills. Here the real portals are link, also external links also added, like the LinkedIn, Upwork, freelancing portals, and etc. links are also added to get a more job opportunities. This is an interview preparation model where the user can update their skills, technical skills, get the HR behavior question, aptitude test, also improve their resume by improving the ATS score, and also improve their communication skills. This system is a single platform where the user can find the relevant job according to their skills. It is a combination of the multiple platform, also the help for the user to improve their skills, and also help a user to improve their ATS score of the resume. This is a features that it also provide and filter option where a user can find out the jobs according to their skills. Also, when the user click on the apply button, simply redirect to the TL portal. It supports the user for the skill development, interview preparation, and the getting the job from the different platform into the single. Overall, this system is give and complete the career guidance to the user to get a job according to their skills, and smartly, efficiently, very user friendly. We can in the future we can also add the machine learning techniques to get a better job recommendation. Also add some natural processing languages to accurately analyze the resume. Also develop the mobile application that user can access this system in from anywhere, not need of any system. Also when the new job is added to the system, the user can get the notification via mail or the app. Also, some AI mock interviews also added to prepare the user for the upcoming interviews and the complete career guidance. We can also add some APIs, also different API keys to make our project more vast and more helpful for the user, and is globally used for everywhere. Here is my presentation. Thank you so much, everyone.
Thank you, Ms. Prashni, for your insightful presentation. Now I request Ms. Aditi Mule to present her paper based on AI-based interview presentation system. Over to you, Aditi Mule.
Yes, ma'am. Good afternoon, all. My name is Aditi Mure from Prerna College of Science, Commerce and Art. I am currently pursuing my MSc Computer Science. Today I am presenting my project on AI-based interview preparation system. In this slide, I am explaining the importance of an interview. Interview are very important for getting job and building a career. But many students face problems like a lack of confidence, nervousness, and poor communication skills. Many times students know the answers, but they are not able to express it properly. Also, they do not get a real interview environment for practice. Like traditional methods like books or coaching classes do not provide instant feedback, so improvement become so
In this slide, I studied existing system. Many systems use artificial intelligence to conduct a mock interviews and give feedback. They also NLP processing to analyze answers. AI is becoming very useful to educations and training system, but still not system have limitations like a lack of a personalization and a less accuracy. So there is a need for a better and more user friendly system. The main problem is that students are not fully prepared for interview. They feel nervous and lack confidence, especially without proper practice. Also, students not get exposed to different types of interview questions. The main object of this project are to improve real interview practice, to improve confidence and communication skills, to give instant feedback, and to track user performance. I am explaining to how the system works. This is the AI-based web application. It includes different interview models like HR, skill-based, and company-based interview. The system works step by step. First is the ask for a question, then a user give an answer, and finally the system evaluated the answer. User can answer using the text and the voice input. The system uses NLP to analyze answers and provide across and the feedback. The feedbacks helps user understand their mistakes and improve step by step. This system implement as a web-based application. Python flags for backend development because it is a simple and lightweight. On front end, I used to HTML, CSS, and Bootstrap to create a user-friendly interface. JavaScript we used to interaction, and chart.js is used to display performance in graphs, and voice input features in implement using web speech API. On this slide is a show to home page of a dashboard of the My System. Here user can see their overall performance like a total interview average source and progress. It also provide easy navigation to different modules. This mistake the system simple to easy to use. This model provide a real interview like environment. In this slide show to HR interview practice dashboard. HR questions are important to the test personality and communication skills. This models helps user reduce fear and improve confidence. And this slide in a skill-based interview user can select any skill like a Python, SQL, Java, data science, machine learning, Python. The system automatically generate a question using AI. This make the practice more flexible and dynamic. It also helps user improve their technical knowledge. You also can upload your resume in this dashboard. In this dashboard, user can select a company and job role. The system generated company specific questions. Different companies have different companies and different interviews patterns. So this help user prepare according to real job
queries. This is the last slide of a mini dashboard of performance analysis. That's overall the interview performance of a user. This dashboard shows user performer using charts and graphs. It displays detail like the total interview, base scores, overall grades, average scores, data visualization, helps user understand their state and weakness easily. Is also motivated user to improve continuously. In this conclusion, this system provides a smart and effective way to prepare for interview. It combines AI technology with educated to solve real world problems. It helps students improve confidence, communication skills, overall problems. In this future, we can improve the system by adding user login system, video interview feature, facial expressions analysis, and support multiple language. So thank you, ma'am.
Thank you, Aditi. Now I request Ms. Neha Nikhare to present her paper presentation. Neha Nikhare, over to you.
Yes, ma'am.
Ms. Aditi, mute your mic.
Yes, ma'am.
Ms. Neha,
Yes, ma'am.
please start your presentation.
Hello, everyone. Can you please confirm if my screen is visible?
Yes.
Okay.
Open your PPT.
Hello, everyone. Myself, Neha Nikhare. Today's my topic is impact of 5G technology on IoT and smart infrastructure. In today's digital world, technology is growing very fast. This project focusing on studying the impact of 5G technology on IoT and smart infrastructure, highlighting its advantage, challenges, and real world. It is growing very fast. One of the most important advancement is 5G
Neha?
technology. Yes, ma'am.
Your PPT is not visible.
Okay, ma'am. Can we present it from our side?
Can we present it from our side?
Okay. Ma'am, my PPT is visible?
Yes, yes.
Please start from your title.
Okay. In today's digital world, technology is growing very fast. One of the most important advancement is 5G technology. This project
Neha,
focuses.
please
Yes,
show
ma'am.
the title of your paper. First
Yeah,
slide of presentation.
Yeah, ma'am. Okay. The title of my research project is Impact of 5G Technology on IoT and Smart Infrastructure. This project focuses on studying the impact of 5G technology on IoT and smart infrastructure, highlighted most the advantages and challenges. As a fifth generation of mobile communication, 5G offers ultra-high speed, extremely low latency, high bandwidth, and massive device connectivity. In the fifth generation of mobile network, it is much faster, more reliable, and has very low delay compared to 4G. At the same time, we also seeing the rise of the Internet Things or IoT, where everyday device like smartphones, smart watches, and sensors are connected to the Internet. Evolutions of the mobile networks. 1G introduced analog voice communication. In 2G generations, added digital communications and SMS service. In 3G, we have to access only mobile network and multimedia applications. In 4G, provide high-speed internet, but it has some connectivity problem and video streaming and social media. 5G goes beyond traditional communication, offering ultra-high speed, extremely low latency, and massive device connectivity entire for IoT. Now, when we combine 5G and IoT, it creates a powerful system that can conform and transfer our cities into smart cities. The problems were faces in 1G to up to 4G generations, limited capacity, high latency, energy efficiency, and lack of dedicated infrastructure. The biggest advantage of 5G, it is high speed and it has very low latency. It means it is up to 1,000 times faster than 4G. This means IoT devices can send or receive data instantly within a 1 millisecond. For example, in a smart home, devices like lights, fans, and security system can respond immediately without any delay. Objective of the research paper: reduce latency for real-time control, increase network reliability, boost data transfer speed. By offering significantly higher bandwidth than 4G, 5G enables the rapid transfer of large data within a 1 millisecond. 5G support massive connectivity. It can connect millions of devices in a small area. This is very useful for smart cities where thousands of sensors are used for traffic management, pollution monitoring, and public safety. The rapid evolution of wireless communication has led to the development of fifth generation technology, which is designed to offer significant improvement over its preceding in terms of speed, latency, and connectivity. Smart electricity grids can manage power usage efficiently and reduce energy waste. Smart water system can detect leaks and save water. IoT refers to a network of interconnect devices that collect, transmit, and analyze the data which we collected from other sites. Research is ongoing to address the challenges of 5G, such as security related to the vast number of connected devices, optimal network architecture like network slicing and minimizing energy efficiency. Areas like quantum communication and satellite research are also being explored in conjunction with 5G to enable seamless connectivity in remote or previously unconnected locations. Studies also had challenges such as high infrastructure costs and cybersecurity threat. Another important benefit is automation and use of artificial intelligence. Data collected from IoT devices can be analyzed to make better decisions. For example, problems in road or bridges can be detected early, which help in maintenance and prevents accident. The setup of cost housing infrastructure is very high. Also, as more devices are connected, there is a risk of cybersecurity and privacy issue. It includes all the physical hardware that interacts with the real world. To provide the network infrastructure for devices to communicate with each other, device to device, and to transmit their data to a server. To
Ms. Neha,
yes, ma'am.
you have 1 minute left to conclude your paper.
Okay. The result is testing approach. Objective of testing verify that this simulator correctly calculate RTT, that is round trip time, and throughput for both 4G and 5G network. Network profile defined for 4G and 5G with adjustable parameters, that is latency and bandwidth. In conclusion, 5G technology is not just faster internet, it is a key technology that will support the growth of IoT and helps in building smart and sustainable infrastructure. It has the potential to improve our daily lives by making cities safer, faster, and more efficient. Okay, ma'am. Thank you.
Thank you, Ms. Neha Nikhare. Now I request Mr. Anurag Bharti to present the paper titled Accommodation Management System for Large-Scale Events. Over to you, Mr. Anurag.
Thank you, ma'am. Good afternoon, all. All right, just give me a minute. I'll present my screen.
Okay.
Please let me know if my screen is visible.
Yes, yes. It is visible.
All right, so I'm here to speak upon a very important aspect in events industry, that is accommodation for large scale events. What generally happens is when we are getting involved in large scale events that go on for a day or two, accommodation is a very important factor in them. Because if people are enjoying in their events, having good time in conference, they really need to rest. And if the resting time is not well appreciated, the delegates, they start to complain, which is a huge chaos at the time of the event. So, as I was saying, attending a national level event is very exciting. But as I am trying to tell how chaotic it can be, organizing such large scale events is also very risky and needs a lot of attention and management as well. When it comes to accommodation, it has to be precise, it has to be to the point, because no delegates would want to experience a shabby hotel after attending a conference of the whole day, and they don't get a proper good night's sleep, or they don't get proper food or something like that. So what exactly the problem is in the traditional accommodation system that a lot of people, a lot of management teams use in events is using the old way of managing accommodation using Excel sheets, using pen and paper, which becomes chaotic because there are many problems such as double booking, whereas one nodal officer in one hotel, he allots a room, and the updated sheet hasn't reached the next nodal officer in the next hotel. So he assigns the same room to a different person. Now, there is one room that is assigned to two different people, which becomes very chaotic when those two delegates clash in the same room, and no one would really want that, to be honest. So what the industry has come up with is an centralized database accommodation management system. Now, this management system is actually based upon a three-tier dependent architecture where there's a presentation layer, then comes a database layer, and then comes a logic layer. The presentation layer, as we can see, is an interface and public interface that delegates interact with while filling up their form for accommodation, while requesting accommodation. And it is also the layer that gives updates to the delegates on their own personalized and unique dashboard. So to manage this particular accommodation thingy, we really need to be very precise, as I told you guys. The 1,000 delegates are attending a session, so it becomes very chaotic while assigning rooms specifically to one singular person in such big events. Then we come to the database layer. The database, as I told you, should be a centralized database that initially takes information from the delegates who are filling up the form. The data filled up in the form is getting stored in the database, which I'll explain it how in the next slides. This data that is being fetched from the delegates using a form is then sent to the backend where the the admins from the accommodation committee can review the requests obtained from the delegates, and they can assign the rooms and the hotels to them. Let's look at it in deeper. So this is the interface. Interface. Generally, what would happen is the interface has to be very secure because a lot of delegates are involved in this. What happens is they land up on the landing page. They come to the landing page. They fill up the form as shown in this image, the accommodation booking image. There are also many validations that they need to go through, such as membership verification shown over here. Then the field validation, such as over here. And once they fill up the accommodation form, they have their own dashboard, as seen over here, where they can see updates on their accounts. So if the admins update their accounts, allot rooms or hotels, it can be seen in the dashboard that they have that they get. Then we come to the logic tier, which is the backend of the system, which is the actual commanding brain. Now what happens, this system is a access control system which is given to few individuals from the accommodation committee who have the power to edit. As you guys can see, they can overview in this dashboard. A dashboard is created where they can overview how many bookings have come, how many bookings have been approved, cancelled or pending. And they can also edit in the booking management section over here where they can approve an accommodation request, they can allot an accommodation request, and so on. Similarly, we have a hierarchy system over here to maintain the integrity of the system, whereas there is a super admin system and staff system and admin system. The super admin has the complete control of the system, and accordingly there is admin who has limited control, then the nodal officers who have much more limited control over the system. Then we come to the database tier. The database, as I told you, is the most important part because it has to be centralized. It has to work in real time to share the information between the nodal officers, the admin team, and the delegates too. and it should be so precise that there should not be any mishaps in between, otherwise it would be a chaos. So we have a main database that has 3 different tables. I'll explain these tables later in the next slide. Then we've got an bookings database table that captures the information of specific individuals, like one particular delegate. His all information is captured over here. Then we've got an admin database that captures the information of the admins, that allows access to the admins, that allows admins the access to the database, the particular database backend system. Sorry. We've got an audit trail, audit logs that records each and every action that happens in the backend by each and every admin to support the integrity of the system. As we were talking about integrity and security, to manage such a huge system and to not leak any kind of data, any kind of mishaps, any kind of cybersecurity issues to arise, there are many validations, there are many security methodologies, technologies involved over here, such as passwords. One of the most easy one is the password hashing. So that whenever someone is creating their account, whenever a delegate is creating its account, the password that he or she is feeding into the field won't be seen by the admins, by the authorities. So that ensures that the password is specifically to that one individual, and no one other than that particular individual. Then that particular individual can access the password, then can access the user's dashboard. Similarly, we've got a real-time membership validation, which ensures that a person who is opting for accommodation has to be registered for the event. Now, to make this validation happen, we are using an API integration between the registration database and the accommodation request form. So form will fetch the data from the registration database and validate it from there. Similarly, we've got protected backend access. We've got SQL injection prevention data cleanup technology, which specifies that no one can actually get into the database by inputting special characters into the fields, such as these over here, real-time form validation. As you can see, no one can access the database using SQL injection codes. And as I told you, we have an action logging system. So this is an example of that one, where each and every action is being recorded by the system, so that no mishaps in future, no internal corruption leads to any kind of mishap during the during the process. And yeah, that's much more like it. And this is how an upside down system can be turned into a very manageable system and can give you a lot of good experiences while opting for accommodation during large scale events. Thank you, guys.
Thank you, Mr. Anurag, for your insightful presentation. Now I request Mr. Gnandeep Kaule to present his paper based on Pulse Play, real-time gaming analytics and discovery system.
Thank you, ma'am. Just let me know if the screen is visible or not.
No, the screen is not visible. You are visible, but your presentation is okay. Now it is visible.
Okay. If my PPT is visible, right?
Yes, it is visible.
Okay. Okay. It is visible, right?
Yes.
Okay. So hello everyone, my name is Nyanjit Khawle and today I will be presenting my project, the Pulse Play. It is a real-time gaming analytics and discovery system powered by natural language processing. The gaming market is today is currently flooded. Main problems player face is that the stores indeed rely on basic tags. Like as you can see here, it is just an action tag, and both of the games come under action tag. Even though one is related to farming and other is a shooter kind of thing. If you search action games, these results are too broad and lack content. Furthermore, gamers have to check 3 or 4 different websites just to find out the game is active and where it is cheapest. My goal is to solve this problem. To address this issue, I have developed Pulse Play. Instead of just matchmaking tag, Pulse Play acts as a smart assistant. It uses AI to read game descriptions to find out the true matchings, while simultaneously acting as a live dashboard that shows real-time player counts, the cheapest active deals, and allows user to bookmark their favorites. This is the front interface of the Pulse Play system. Next, moving on to system architecture. Looking at the architecture, I have built the backend using Python and Flash frameworks because it is incredibly fast and secure logins perfectly. All of the local data, including passwords and saved bookmarks, and the entire game catalog is stored efficiently into SQL-like database, which then dynamically feeds data into the front end using Jinja 2 templates. Moving on to the engine. The core Pulse Play engine relies on 2 things. First is API and second is live data. So instead of using tags which most of the stores use, I have used natural language processing model like Allmini ML v2, which I got from Hugging Face. It reads the game descriptions and converts them into math using cosine similarity. The app finds the games which are same exact narrative vibes simultaneously. The app talks to the live API over the internet to fetch the high quality posters, current player counts, and the cheapest live store prices. Moving on, after user have searched, this brings us to our final platform. For the user, I have built a dynamic and fast interface which search games for them, where user can save the games in their arsenal, or after they are searched, they will get the live deals of the game and recommendation according to it. Just to help that how much data is stored in our database, I have also provided a chart kind of format for the user to get the idea of how much data is available on platform. Or if user wants, they can even add games which will fetch data through API. Moving on for the conclusion, ultimately Pulse Play proves that a smart system can be built by using APIs and mix all the different platforms at one place. The next phase of this platform, I think, would be to make it publicly available and implementing more API models so that user can access more data. The another would be, instead of just relying on game description, we can rely on user reviews that would be more accurate and more authentic to get recommendation. Next, here is a live demo of how Pulse Play looks like. Here, this is the homepage where user can type and search for the games they want. They will get recommendation according to it, and AI will analyze the game description to get the deals and recommendation. After that, here, the user can see the live active players and live deals. There is also ratings for games and their categories. user can also see the other recommendations, and if they click on it, they can add it to their arsenal or get the live deals by clicking on it, and it will take you to buy page of the official website. And thank you for everyone to listening for my first play presentation.
Thank you, Nandi. I request Dr. Barhate ma'am to give her remarks on participants' paper presentation. Over to you, ma'am.
Yes, good evening, everyone.
Good evening, ma'am.
All the respected members, head, and my fellow professors and dear students. It was such a feast for all of us to engage in many research ideas, starting from Ms. Prashni Naidu, a cross-platform job aggregator system, application tracking system. Aditi Mude, she worked on AI-based interview presentation system. Ms. Neha Nikhare, impact of 5G technology on IoT and smart infrastructures. Anurag Bharti, accommodation management system for large-scale events. And Nyandeep Khavle, Pulse Play real-time gaming analytics and discovery system. It is a really wonderful opportunity for all the MSc students to present your research work as such a standard platform. Had it been in-person conference, we would have really enjoyed more to have a in-person communication with all the research students. We at the department make a point that all the students who are making their who are into their research project, they present their research ideas at a national conference or international conference, whichever is convenient or available to them. And I really congratulate the conference team for providing such a wonderful opportunity for the students to present their research work at such a esteemed conference. It is truly an honor to serve as a session chair for the esteemed conference. I am grateful for the opportunity to contribute and engage with such inspiring scholars and professionals, and I thank the entire team from bits to qubits, quantum computing and beyond, and congratulate the team for successfully organizing this valuable conference. Thank you.
Thank you, Shweta madam.
Thank you, sir.
For accepting our invitation and sharing your insights. Hope you all like this
Definitely, sir.
session.
Definitely. Yes.
And in future, these scholars will come to you only.
Definitely, sir. It would be an honor. Thank you, sir.
Thank you very much.
Thank you, ma'am. I sincerely thank Dr. Barhate ma'am for her thoughtful guidance and her valuable time. With this, we come to the end of our paper presentation session. I extend my heartfelt thanks to all the presenters for their excellent contribution and to respected Dr. Shweta Barhate madam for her valuable time, constructive feedback and thoughtful evaluation. I would also like to thank the organizing committee and technical team for their continuous support in ensuring the smooth execution of this session. Now we move forward to the valedictory session. For that, I, Ms. Rajshri Akre, request Ms. Priyanka ma'am to kindly take over. Thank you all for your participation. I may now take your leave and have a wonderful day. Thank you. Thank you so much.
Thank you, Rajeshri ma'am. Good afternoon, all the respected dignitaries, honorable guests, faculty members, and dear participants. I, Priyanka Chandawar, Assistant Professor from Department of Computer Science from Dr. S.C. Gulhane, Prerna College of Commerce, Science and Arts, feel deeply privileged and honored to serve as the host for the valedictory function of this national conference from bits to qubits, quantum computing and beyond. As we gather here at the culmination of this enriching academic journey, we celebrate not merely the conclusion of the conference, but the vibrant exchange of knowledge, innovative ideas and intellectual inspiration that have marked these sessions. Over the course of this conference, we have witnessed insightful deliberations, thought-provoking discussions, and a shared vision towards the advancing the frontiers of the technology. Now, I humbly request Dr. Urmila Dabir ma'am the respected principal of our college, to kindly present the summary of today's conference. Over to you, ma'am.
Yes, madam is joining in a minute. Please wait.
Sure, sir.
A very good afternoon to all. Esteemed speakers, Director Dr. Praveen Joshi, faculty members, research scholars, and dear students. We have arrived at the valedictory moment of what has truly been intellectually enriching memorable day. The one-day national conference on From Bits to Qubits, Quantum Computing and Beyond, organized by our college. As we gather here for this closing ceremony, I find myself reflecting with a deep sense of gratitude, fulfillment, and inspiration for what began this morning as a gathering of curious minds has today transformed into a vibrant community of quantum thinkers. When we inaugurated this conference this morning, we set out with a shared purpose to explore, to learn, and to envision the extraordinary possibilities that quantum computing holds for the future of humanity. And what a journey it has been. Through the course of the day, our distinguished keynote speakers and resource persons took us on a fascinating intellectual voyage from the very foundations of quantum mechanics and the mystery of superposition and entanglement to the cutting-edge frontiers of quantum algorithms, quantum cryptography, quantum machine learning, and beyond. Each session opened new doors of understanding. Each paper presentation challenged us to think deeper. Each panel discussion encouraged us to question, to debate, and to discover. This enthusiasm and active participation demonstrated by our delegates, students, and faculty throughout the day has truly been the heartbeat of this conference. The discussions today have reinforced one powerful truth, that quantum computing is no longer a subject of science fiction. It is a rapidly advancing field that is already beginning to reshape industries, redefine security, and revolutionize scientific research. We learned that while classical computers excel at processing information in a linear binary manner, quantum computers harness the strange and beautiful laws of quantum physics to solve problems that would take classical systems millions of years to crack in a matter of seconds. We understand that nations and institutions that invest in quantum literacy today will be leaders of tomorrow's technologies. And today, Prerna College proudly affirmed this commitment to being part of that future. I take this opportunity to extend my heartfelt gratitude to our eminent keynote speaker, resource persons, whose expertise, passion, and clarity of thought made every session truly enlightening. The organizing committee, the faculty coordinators, whose months of dedicated effort made this event a grand success. I also congratulate Dr. Revatkar, HOD, and his team for successful organization of this team. All the paper presenters and delegates who brought their research and ideas to this platform. And most importantly, each one of you for your presence, your participation, and your spirit of inquiry. As we step out of this conference, let us carry forward not the knowledge we have gained, but also the wonder we have rekindled. The wonder that drives every scientist, every innovator, every great mind. It is rightly said, imagination is more important than knowledge. Knowledge is limited. Imagination encircles the world. Today at Prerna College of Commerce, Science, Arts and Imagination met knowledge, and the result was nothing short of extraordinary. Thank you very much.
Thank you so much, ma'am, for the comprehensive and insightful summary, which beautifully encapsulated the essence and outcomes of this conference. At this juncture, I respectfully invite Dr. Praveen Joshi, sir, the respected director of our college, to share his valuable remarks. Over to you, sir.
The principal of the college, Dr. Orginising, the HOD, Department of Computer Science, Dr. Valedictory, the faculty members, the scholars, and delegates. It was a very meaningful and fruitful day. The plenary sessions that we have had have certainly given us new insights into the area. All the plenary sessions have also provided clues as to how research can go ahead in this field. As we are leading from classical bits to qubits and beyond, that is super quantum leap, the world is going to witness tremendous phenomenon, so many wonders that will take place in future. I, being a student of humanities, I would always think that way. Human behavior. In future, this quantum computing is going to study human behavior at different levels. If we take into consideration our brain and the memory that it stores, the quantum computing will help us a lot to understand the different functions, the different units of human brain that are functionary, that function to guide and govern human behavior. In fact, memory is not stored in any one part of our brain. The first part that comes is hippocampus. Hippocampus is the area in which short-term memory is stored. Then we have neocortex. After that comes one more area that is very important, that is called prefrontal cortex. And there are so many other areas. A day will come when the overall behavior of human beings will be studied with the help of this quantum computing. Suppose there is a boy of 18 years. So his brain will be studied, how he behaved at different situations, at different times, and his behavioral patterns, and then his future can be described as to how he will behave in future also. So it is going to cover a large area of human behavior. I am sure that research in this direction also will take place, will inspire the scholars to take this area for research and work sincerely to find out what exactly will be the results if we take this particular area for studies. Research being the soul of the progress of any country, we must undertake more and more research, and this bits to qubits and beyond, this particular topic will give you a lot of ideas for choosing your research topics. I congratulate all the participants who have been listening to the resource persons and other speakers right from the morning. I congratulate Dr. Revatkar and his team for very successful organization of this conference. I am sure that when you go home, you will have new ideas in your mind and you will certainly give a concrete shape to your ideas and will have further studies in this particular area. All the best to all the participants and thank you very much for patiently listening to me. Thank you.
Thank you very much, sir, for your thoughtful insights and encouraging words. As we conclude this conference, let us carry forward the knowledge we have gained and continue to explore, innovate, and contribute to ever-evolving world of science and technology. With this, I take your kind permission to step down from virtual dais. It has been indeed a privilege and a wonderful learning experience to be a part of this intellectually stimulating e-conference. Thank you all for your gracious presence and active participation. Now, I request Dr. Liladhar Revatkar sir for a formal vote of thanks. Over to you, sir.
Thank you, Priyanka ma'am. Am I audible?
Yes, sir.
Okay. So, Chief Guest of the Valedictory function, respected Director of our college, Dr. Praveen Joshi sir, our distinguished keynote speakers, Professor Dr. Ashish Mishra, Department of Computer Science and Engineering, GG Institute of Technology and Sciences, Jabalpur, Madhya Pradesh, our esteemed session speakers, Professor Dr. Ishwar Baidari, Professor Dr. Nilesh Sabe, and Professor Dr. Rabin Sporwal, respected session chairs, Dr. Ravikant Jubele, Dr. S.B. Kishore, and Dr. Ashish Sasankar. Also, the chairperson of the paper presentation session, Dr. Shweta Bharate, respected principal, Dr. Urmila Nabir Madam, and all faculty members, distinguished delegates, research scholar, paper presenter, and dear students. A very good evening to all of you. As the final chapter of this remarkable day unfolds, I rise with a heart brimming with gratitude, joy, and deep satisfaction to deliver the vote of thanks on behalf of Dr. S.C. Gulhane, Prerna College of Commerce, Science and Arts, and the entire organizing team. We began this morning with the promise of a journey from the familiar world of bits to the extraordinary world of qubits. And today, that promise was kept in full measure through thought-provoking keynotes, enriching technical sessions, vibrant paper presentations, and stimulating discussions. This conference has truly lived up to its theme from bits to qubits, quantum computing and beyond. But a day of this magnitude is never the effort of one. It is always the symphony of many, and it is my honor to acknowledge every one of those many with the gratitude they so richly deserve. We begin our acknowledgement with our chief guest for the valedictory function, Dr. Praveen Joshi sir. Sir, your gracious presence at the valedictory function has lent the perfect sense of dignity and distinction to the closing of this conference. Your words of wisdom and your perspective on quantum computing, research, technology, and academia have given our participant a beautiful and inspiring note to carry home. On behalf of the entire institution, a heartfelt thank you to Dr. Joshi sir. Our deepest gratitude goes to our keynote speaker, Professor Dr. Ashish Mishra, Department of Computer Science and Engineering, GG Institute of Technology and Sciences, Jabalpur, Madhya Pradesh, who set the intellectual tone and direction of this entire conference with his outstanding address. Sir, your keynote was nothing short of enlightening. You effortlessly bridged the gap between complex quantum theory and the real-world applications, making the subject both accessible and deeply inspiring for every person in this conference. The clarity of your thought, the depth of your knowledge, and the warmth of your delivery made your session the cornerstone of today's program. We are immensely grateful for your time, your wisdom, and your passion. Thank you, sir. A warm thank you to Professor Dr. Ishwar Baidari for his outstanding and informative first plenary session. Your deep expertise and the clarity with which you presented your idea made session 1 an intellectually rich experience for all attendees. We are equally grateful to Dr. Ravikant Jugale for his exemplary role as chairman of session 1. Sir, your thoughtful moderation and expert felicitation ensured that the session flowed with both depth and direction. Thank you both for your invaluable contribution. We thank Professor Dr. Nilesh Sabe for delivering an engaging and knowledge-rich second session. Your insights opened the new dimension of understanding for our participants and sparked meaningful conversation that continued well beyond your session. We extend equal gratitude to Dr. S.B. Kishore, the chairperson of session 2, with sharp academic acumen and skillful conduct of the session created an environment of active learning and scholarly exchange. Your combined effort made session 2 truly memorable. Thank you, sir. A very special thanks you to Professor Dr. Ravin Porwal for his illuminating technical presentation. Your session took our audience to the frontier of quantum computing and indeed beyond, inspiring researchers and students alike to think bigger and dream bolder. Our sincere gratitude also goes to Dr. Ashish Sasankar, the chairperson of the third session, for his exceptional moderation, academic leadership, and the energy he brought to the session. Under your guidance, the session concluded on a high note of intellectual enthusiasm. Thank you both. Your contribution made session 3 the perfect crescendo of today's technical program. One of the most vibrant and energetic segments of today's conference was the paper presentation session, and at the heart of its success was Dr. Shweta Bharate. Madam, your meticulous coordination, patient guidance, and professional management of the paper presentation session gave our young researchers and scholars the platform they deserve to showcase their work before a national audience. Your encouragement and constructive feedback made every presenter feel valued and motivated. Thank you, madam, for nurturing the research spirit in our young mind. We owe a very special words of gratitude to Principal Dr. Urmila Ravir, madam, the guiding force and visionary leader behind this conference. Madam, your inspiring welcome address this morning beautifully captured the essence of our theme and set the perfect tone for the day. Your constant encouragement, academic vision, and institutional leadership have made our college a space where events of this national significance can flourish. This conference is as much your achievement as anyone else. Thank you, madam. We express our profound and sincere gratitude to respected Professor Harsi Gulhane sir, the chairperson of Prerna Seva Mandal, and respected Dr. S.C. Gulhane sir, Honorable Secretary of Prerna Seva Mandal, and all members of the governing body for their generous support, encouragement, and belief in academic excellence. It is your vision that drives our college forward into new frontiers of the education, research, and national relevance. This conference stands as a living example of that vision in action. Thank you for your unwavering support. Behind every successful conference is an army of dedicated faculty members and technical teams who give their time, energy, and expertise without expectation of applause. To the entire organizing committee of the college who contributed to the planning and execution of today's program, from designing the brochure to coordinating registrations, managing the virtual venue, and preparing the technical proceedings. Your invisible effort made everything visible today. We see your work. We appreciate your dedication. Thank you from the bottom of our heart. Our sincere thanks to all the delegates, participants, and paper presenter who participated in this conference. Your presence gave this event its national character. Your questions enriched the session. Your research contribution advanced our collective understanding, and your enthusiasm and energy filled this virtual hall with the spirit of true academic inquiry. A conference is only as great as its participant, and today our participants were truly great. On behalf of the college, the organizing department, and every member of our team, we thank everyone for making this national conference on From Bits to Qubits, Quantum Computing and Beyond, an event we'll remember with the pride for years to come. We look forward to welcoming you again. Thank you all, and with the permission of chair, I conclude this conference. Once again, thank you to all and good evening.
With this, the conference is over. All the staff members can go back home.